Hello, welcome to our first module of the Linux Plus training course. Our course is going to be composed of 15 modules, and the first module is going to be a very simple module where we're going to see how to install the Linux operating system. Specifically, what we're going to do is install the Ubuntu distribution. And in our second module, we're going to discuss more about Linux distributions, the Linux operating system, its architecture, how it works, some basic concepts that are required in order to use the Linux operating system. However, before we actually start discussing those concepts and using the system, we want to have the system installed. We could adopt two different approaches here. We could just run a running virtual machine, a virtual machine that you'd just need to download, open it, and run it. The installation is already there, so you wouldn't have to go through the installation process. However, we believe that going through this process is very important in order to get used to the operating system. And obviously, because it is a process that is required for the Linux Plus certification. So our first module is going to be installing the Linux operating system, although we don't have all the concepts that are required in order to fully understand some steps. I will briefly mention how those steps work and just introduce a few concepts, but we're going to discuss that in more details in another module. So you have different options to install the Linux operating system. We're going to use a virtual machine. To run Linux as a virtual machine, you need a virtualization software, such as the one that you can see here, VirtualBox. So the website is virtualbox.org. And here you can simply download and install this software according to your operating system. So VirtualBox 6.1.2, at this moment, this is the current stable version. There are some other versions, older versions. There is a testing newer version, but I strongly advise you to download the current stable version, which is at this moment 6.1.2. So according to your operating system, you simply click here. So let's say that you're using a OS X system. So you click there and you're gonna download it. Once it's been downloaded, you just double click it and proceed with the installation. So it's very simple, just like installing any other software. There is no secret here. Once you have VirtualBox installed in your machine, the idea here is to use this software to create a virtual machine, which is, as the name says itself, it's a machine that is not physical. It doesn't physically exist. It's just virtually running on top of your physical machine. So you have your machine. In your machine, you're running your operating system, which can be a Windows, Mac OS X, Linux, Solaris, Unix. It doesn't matter, any operating system. On top of that operating system, which is the one that you use daily, you're going to install another software, in this case VirtualBox. You could use VMware, you could use other virtualization softwares. We're adopting VirtualBox because it's so easy to use. It's pretty straightforward. So On top of your operating system, you're going to run a virtualization software such as VirtualBox. Using VirtualBox, we're going to create a virtual machine, which is going to be the virtual machine in which we're going to install the Linux operating system, specifically Ubuntu. Now, in order to do that, we have to download the Ubuntu ISO image. So here, this is the Ubuntu website, ubuntu.com. And why are we adopting the Ubuntu distribution? There are so many other distributions. You have Ubuntu, you have Debian, you have CentOS, Red Hat, Slackware, Mint. There are so many distributions. You should pick it according to your requirements, your necessities, or your desire. But the reason why we're picking Ubuntu is because Ubuntu is a distribution that can be used in servers, but it can also be used in desktop machines. It's a very friendly distribution, and at the same time, it's a performable distribution. It is secure, it's performable, and at the same time, it delivers to the end user a very pleasing environment, a very friendly environment. And there are so many tools available to help you manage your system, graphical tools that would just make your managing tasks easier. So that is why it became such a huge distribution. Now again, regarding the other distributions or regarding the main other distributions, we're going to discuss in our following module, where we're going to see some Linux basics and basic concepts. Okay, so once you're here, you go to download, click on that arrow, and you're going to see so many options here. Now, overall, you have four main, there are more, but overall you have four main Ubuntu versions or types according to your requirements or your necessity or your environment. You have Ubuntu Desktop, Ubuntu Server, Ubuntu for IoT, Ubuntu Cloud. As you can see, based on the names, according to what you want to do, you have a specific Ubuntu version. So if you're installing Linux to use it as a desktop, you have Ubuntu Desktop. To use in a server, in a bare metal server, you have Ubuntu Server. Depending on the type of architecture, if you want to install it in a IoT device, you have Ubuntu for IoT. If it's supposed to be a cloud system, you have Ubuntu Cloud. Well, we're gonna download the Ubuntu Desktop version, and here you can see two main versions, although there are others, older versions, 18.04 and 19.10. Which one should you pick? If you want to pick 19.10, which is the most recent stable version, you can. The problem is it is not a LTS version. LTS stands for Long Time System. It's a system that has the support or long time support. The support lasts for 5 years. And here you have support for 6 months. So they're basically 19.10 has some updated softwares when compared to the software versions that comes in 18.04. However, the support is shorter because it's not LTS. Therefore, I'm going to download 18.0 LTS. That's what I would tell you to do. But once again, if you want to download 19.10, that's perfectly fine. Okay, so I will click it there. and there it is. It will automatically start the download process. I already have the software, the ISO image here. So what I'm going to do is go to my VirtualBox and start the process of creating my virtual machine to then start the installation process. Okay, so here it is. Don't bother about these two virtual machines right here. These are virtual machines that I already had there. Yours will probably be empty, but once you open VirtualBox, this is the screen that you see. What we're gonna do is create a new virtual machine. So to do that, you simply click on New. So this is the reason why we picked VirtualBox and not VMware, for example, because it's so much easier to use. Now, here you just have to name your virtual machine. Obviously, you should name it according to the intent of that VM. In this case, we're creating a VM to install the Ubuntu distribution. So what I'm going to do here is name it Ubuntu. As you name that virtual machine, VirtualBox will try to, according to the name, figure out what is the system that you're willing to install. Obviously, depending on what you name it, it won't be able to. But okay, so it detected as a Linux operating system type. It's a Linux, okay, that's good. And the version, Ubuntu. Since Ubuntu has been widely adopted when it comes to desktops, that's the default option that it will pick, Ubuntu. Now, the architecture. Nowadays, most architectures are 64-bit, therefore it's correct. Well, it could be Ubuntu 32-bit, you could have other distributions. So here you have a few examples of known distributions, such as Arch Linux, Debian, OpenSUSE, Fedora, Gentoo, Mandriva, Red Hat, Turbo Linux, Xandros, Oracle. And then if it's not in the list, you could simply pick or the other Linux according to the architecture, 32 or 64 bits. But once again, it is Ubuntu 64-bit. If you have a very old machine, it's 32-bit. You should be able to find out what your architecture is, whether it's 32 or 64-bit. So you have to make sure that you know that before you get to this step right here. Now, that's all set up. I continue. It's gonna ask you how much RAM you need. Now let me go back here and if you go here to Ubuntu Desktop, instead of clicking, so let me go back there, instead of clicking here in the download button, I go to Ubuntu Desktop to see some more information about the Ubuntu Desktop 18.04 LTS. So if we take a look here, recommended system requirements, 2 gigahertz dual core processor or better, 4 gigabytes system memory, 25 gigabytes of free RAM, of free hard drive space, either DVD drive or USB, internet access is helpful. What matters to us here is this. That's recommended, that's not the minimum, okay, but that's recommended. So you should have at least a dual core 2 gigahertz processor, 4 gig of memory, RAM memory, and 25 gig of free hard disk space. So let's bring this up to 4 gig of RAM as requested. If you don't have such a powerful machine, so let's say that you have a 4 gig machine and you want to define it as you only have available, let's say, 2 gig. Okay, that's fine. That's perfectly fine. It will work. As I mentioned, what you see in the website is the recommended. It's not the minimum. The minimum is 1 gig. So, okay, but let's follow if you can, follow what is recommended. There it is. Then you continue. It's going to ask you about the hard drive. And you have a few options here. For option number 1, do not add a virtual hard disk. Create a virtual hard disk now or use an existing virtual hard disk file. Well, you're going to pick the second option here, create a virtual hard disk now. Do not add a virtual hard disk is an option that you can pick if you have full control of what you're doing. It's a more complex option. In the second option, it will create a virtual hard drive for your virtual machine. Now, if you already have a VMDK, there are some other extensions, but when it comes to VirtualBox, by default, the extension is VMDK, virtual machine disk. That's what the extension stands for. If you have an existing virtual hard drive file, you can select this option here and point out to the virtual hard disk file that you have. Okay, that's not our case, so I'm going to pick this option here and create that disk. It will ask you about the format. You can have virtual disk image, VirtualBox disk image. This is specific for VirtualBox. You can have virtual hard disk or virtual machine disk. This option here is, as I mentioned, specific for VirtualBox. But if you have, let's say, you want to be able to port this hard drive to VMware software, for example, you could pick this option here. We're going to just use the default, which is VDI. Continue. Now, how do you want to allocate that hard drive space? Let's say that we're going to follow what's being recommended by the Ubuntu website, which is, okay, I will have a 25 gig of hard drive. How do you want to allocate that space? Do you want to create a file of 25 gig when you create this virtual machine, which would consume 25 gig of your physical hard drive of your partition as you create the virtual machine? Or do you want to dynamically allocate that space as the virtual machine needs while it's growing? So dynamically allocate is better because it's not going to create a 25 gig file. It will create a file of the size that is required as the virtual system requires. So let's say that after the installation process, the virtual machine, the Linux, the newly installed virtual machine is consuming, let's say, 5 gig. You will have in your physical hard drive, in your partition, a file of 5 gig. If you pick fixed size, it doesn't matter how much space the virtual machine needs, it will create that 25 gig file. So you're going to pick this option here. What is the difference between, in regards to space, it's a lot better to use dynamically allocated. What if I use fixed size? You're going to have some performance gain. It will deliver a better performance if the system doesn't have to allocate space during the process of running the virtual machine. So I'll pick this option here. Okay, now size 25. How do you want to name this hard drive, this virtual hard drive? I will just use the same name as my virtual machine name, and I create it. There it is. You can see the virtual machine there. Now I'm gonna go to settings, and it's going to open this option over here. Just a few configurations, or just a one check that we have to go through. First of all, we're gonna go to network. Here in network, you just have one adapter. You have enable network adapter attached to NAT. That's perfectly fine. If you have this option here, your internet connection is going to work. You can just leave it as is, but just make sure that you have a interface, a network adapter enabled, and the option is either NAT, NAT network, bridged adapter. Use one of these options. The other ones would also work. You just have to make sure that not attached is not selected. Okay, so I'll just leave it as is. Now, a configuration that we do have to do is go here in storage. So I'm going to click here. Controller IDE, and you can see a CD-ROM icon right there. I'm going to click it here. So in order to install Linux, or any operating system actually, you have to configure the machine, in this case, the virtual machine, you have to tell it, okay, this is where a installable ISO image is, or a CD-ROM is. I have a CD-ROM here, or CD-ROM drive, and this is where you should read my my bootable system, the system that will be used to run the installation process. Well, since in our virtual machine, let's assume that we don't have a CD-ROM, you don't have the media. We do have the ISO image that we downloaded from the Ubuntu website. So what we have to do is click here on empty. Now, optical drive, no, it's not an optical drive. I'm going to click here, and there it is. Choose virtual. If it doesn't show it here, you click on choose virtual optical disk file. And then you go there and you select your ISO image file. Now, there it is. What is it going to do? When you start the virtual machine, when you run the virtual machine, it will look for a bootable system, a system that would either be bootable or would initiate an installation process. Now it will be able to find it because it's right there. We just pointed out to it. Okay, so I click OK. The machine is there, and then I start. From now on, everything that we do is just like doing in a physical machine. It doesn't matter if, okay, it is a virtual machine, but it doesn't matter. Anything we do is the same as doing in a physical machine, because that's what it's supposed to do. Run a virtual machine, but it's still a machine. Do the same things that you can do in a machine. And then we click on Start to go through with our installation process. And we're going to have a different video to show the installation process. We don't want to make this video so long. Thank you very much. Okay, welcome to our second lecture from our module 1. And here we're going to actually run the installation process. We're going to go through the installation process. So going back to where we were doing at the end of the first video, We have our VirtualBox here. Our virtual machine has been defined. It's been created actually, but there is no operating system running in this virtual machine. That's what we want to do. We want to install the Ubuntu operating system. We're going to simply click there on our virtual machine and click here on Start. It will load. It's just like pressing the power on button on your physical machine. It will load this screen, which is booting the installable system. So we have to wait a few seconds. Obviously, it will depend on your machine configuration, on your CPU, RAM, and basically on your physical resources. And you will face, so let me just drag this here. You will face for a few seconds this black screen while it's loading some modules, some softwares, until you see this screen right here where you read install. Now, basically, you can use the Ubuntu ISO image to do two basic stuff. One is install Ubuntu, which is what we're going to do. When you install the system, you make that system permanent in your hard drive. So the files that are required to use the system will be copied to your hard drive. You will never have to use this ISO image again, at least not to install the system once it's installed. The other option is try Ubuntu. Try Ubuntu is you will run a live system. That means that this system will be copied to the RAM. It will be in your memory, so it's temporary. As soon as you reboot or turn off the virtual machine, that system is gone. So it's a live system. What we're gonna do is install Ubuntu. In this step, you have to pick your language. So I will leave English as default, as our language, and click on install Ubuntu. And then we'll move to the second step, which is defining your keyboard. Now, according to your location, you have different types of keyboards, different layouts, and you have a testing field right here. Okay, so you can test if your keys are according to the layout that's been selected. So you do some tests here. Okay, it's working. I'm pressing the semicolon, column, quotes, and it's all working as expected. So I just continue. Now the second step is defining your installation type. Most distributions, and Ubuntu is just the same, it's not different, you have some predefined installation types. These predefined installation types are actually a selection of softwares that shall be installed during the installation process. So for example, here you have the normal installation where it will install a web browser, which means that it will install a graphical environment. To run Linux does not depend on a graphical environment. It could be run in just a command line based environment. But since we're using a Ubuntu desktop distribution, well, if it's desktop, it's supposed to have a graphical environment. Therefore, you have the normal installation that will install a web browser, some utilities, Office, software, games, and media players. That's what is expected from a desktop version. And you have a minimum installation that will still install a graphical environment, but just with a web browser and basic utilities. So games won't be installed, the Office software is not going to be installed. You have some other options. For example, so we're gonna do So we're gonna do a minimal installation because, well, we're not going to need these other softwares here. Actually, we're not even going to need at first a graphical environment, but it will be helpful during the course. But that's all that we need. The command line interface, the graphical interface, and the web browser. That's more than enough. Some other options: download updates while installing Ubuntu. This is a good option. You should leave it checked. This saves time after installation. And you can also install third-party software for graphics and Wi-Fi hardware and additional media formats. We're not going to do this. If you have, let's say that you have a Wi-Fi interface that is not a common Wi-Fi interface. It's from a different, not known vendor. The chipset is something different from what is available in industry. So you would have to pick this option here. So we continue with our installation process, and regarding what to do in your hard drive. This computer currently has no detected operating systems. What would you like to do? Erase disk and install Ubuntu? Warning, this will delete all your programs, documents, photos, blah, blah, blah. Okay, so this is the situation because the Ubuntu installer was able to detect that in our virtual hard drive, it's not the physical hard drive. Remember, we're installing it in a virtual machine that's just being created. There is a hard drive, a virtual hard drive, but that virtual hard drive is empty because there is no operating system installed. So it's just telling you, okay, this is the best option because the disk is empty. However, if you do have some stuff there and I can't see, be aware that those files will be deleted. Encrypt the new Ubuntu installation for security. If you want to encrypt the partition, use LVM with the new Ubuntu installation. We are actually going to have a class discussing LVM, but the idea of LVM is allow you to post-installation, once your system is running, you are still able to reduce a partition size, increase a partition size, merge two partitions, so you can play with your partitions in your hard drive in regards to space and size. Or you can do something else. It would allow you to do some more advanced and manual tasks. Okay, so erase disk and install Ubuntu. Install now. Now, it is alerting you that if you continue, the changes listed below will be written to the disks. Otherwise, you will be able to make further changes manually. The partition tables of the following devices are changed. So you have one hard drive, again, virtual hard drive, which is identified as SDA. Once again, we're going to have another class where we're going to discuss how the Linux system names disks and partitions. So if it's a SCSI or SATA hard drive, it will define as SD. And then you have some options. The first hard drive is going to be SDA, the second one SDB. Well, not precisely that way. It's not like the first one is SDA, the second one SDB, the third one SDC. It will actually depend on the controller that you have the SCSI controller, the SATA controller, the IDE controller that you have, according to that controller, you have a letter associated with it. But by default, your hard drive should be connected to your first controller, the first connector of your first controller, so SDA. And then you have the partitions inside that hard drive. The following partitions are going to be formatted. Partition 1 will be ext4. And it doesn't say here, but it will be created as SDA1 because it's partition number 1. Once again, if you see SDA5, does that mean that it's the 5th partition? No, it does not mean that. We're going to discuss that in more details in another module. Okay, that's what we need. We click on continue. Where are you according to your time zone? That is my time zone, so I'll just leave it as is. But if you're in a different time zone, you can use the cursor to click here and select your time zone. There it is. Obviously, all these setups can be changed post-installation. Some are very easy to do, some are much more complex, especially when it comes to resizing the hard drive, but it's doable. Now, it needs to know some information about yourself, because the way that Ubuntu works is you need a regular user account in order to use the system. There are distributions that you do not need a regular user account. You can simply use the administrative account, which is the root account. Here you need a regular user account. So your name, you're going to write your name here. I'm going to write Linux. Your computer name, Linux-VirtualBox, that's fine also. Okay. Pick a username. I will use Linux. You can just pick the username as you want. Choose a password. I am also going to use Linux. And you confirm it. Okay. It's telling you that this is a very short password, but that's okay. Now, do you want it to log in automatically, or do you want it to require my password to log in? This is the best option. The difference here is once you boot the system, do you want the system to automatically log into the graphical environment using this user here? Or even though there is just one single user, regular user, one regular user, you want to still require the password. Okay, that's what I want. So I simply continue. And there it is. The installation process is running. It should take a while. Obviously, once again, it will depend on your resources, but it shouldn't take long. And I am going to fast forward once the installation process is done. Okay, so we're back, and now that the installation process is done, you see this message here: installation is complete. You need to restart the computer in order to use the new installation. You simply click Restart Now, and it will boot your system that's just been installed. So let's just see how this booting process works. We're not going to analyze it. We're just going to confirm whether it's working or not. So restart now. You can see here that it shows a message. Please remove the installation medium then press enter. What you have to do here is go back to your machine, to VirtualBox window, click on your virtual machine. It's still running. I go here to settings, storage. Oh, and it's empty. That's what we need. You just have to make sure that the ISO image is not there anymore. Okay, so now we can go back, click there, press enter. And it will boot your newly installed Ubuntu system. You just wait a few seconds, it's booting, and there it is. Your Linux system has been installed, and you're done. If you want to log in, there's your user right there. You click it, you type in the password as you defined, hit enter, and there it is. Your Ubuntu system is ready for use. Once again, according to your physical resources, it can take a while to load, but usually it's just the first time. And there it is. It just is displaying this message here, but you have your environment, your graphical environment ready. Okay, so that's the installation process. As you could see, it's a very easy, straightforward process, specifically when you're installing a Ubuntu distribution. The same goes to distributions such as Mint, for example. That is another distribution that is focused on desktops. If you install another distribution such as, for example, Slackware, it's a completely different process in regards to complexity. It's a much more complex system. Okay, so I hope you enjoyed this class. Thank you very much. Hello, welcome to our Module 2 Lab class. Our goal here is going to be review some commands that we learned in our previous videos, in our previous classes, but also learn some additional commands. It is not feasible to go through all the commands that we have in the Linux environment system in our video classes. So in order to reach out to some additional resources or tools, we're going to use these tools here in our lab class. Additionally, you will also have access to a cheat sheet. So you're going to have access to a PDF file that has some basic Linux commands and the description of those, along with at least one example of each. These commands that you're going to see in that cheat sheet is going to be the basic commands that the CompTIA Linux Plus exam requires you to understand and use. Okay, now, in regards to this lab class, this is the exercises that we will try to answer and make some comments about those. So you can see here 7 questions. They're all technical questions. There is no conceptual question whatsoever. They're all technical. All of them require you to deploy at least one command. At least one. You can use more. There are actually some questions here that will require you to use more than one command. Okay, so let's start with the first one. So it asks you to create an environment variable with any content. Make sure that variable is accessible from another session. Show that it is accessible from another environment. So you have to make sure that that environment variable is accessible from another session you have to show it. So you're not just going to use a command to do it. You have to actually show that it's happening. Okay, so let me go back here to my VM. So I have my terminal here, and the idea is, first of all, we have to create a environment variable. How do we do that? Well, the very basic way is the variable name, I'm going to name it var. And the standard is always use uppercase letters to create Linux environment variables. It's not a rule. If I create this variable like this with lowercase letters, that's perfectly fine. Oops. But the standard says capital letters. Okay, so I'm going to create a variable called var. And the content that I'm placing in there is hello world. Okay, how can I see whether it worked or not? I can, for example, invoke the content of that variable by using the $sign and then the var name. There it is. There's the content. Okay, so I did put a content in that variable, but is it accessible from another session? One way of opening another shell session, you can invoke the bash command, but I'm going to do it a little bit different here. I'm going to invoke the born shell, sh. The bash is the born again shell. The old version of the born again shell, it was the born shell, and it's accessible. It's available in all Linux distributions. You can simply invoke the sh command. There it is. So how do I check the content of a variable? Echo var. We can see that there is no content there. It means that variable does not exist. So I'm going to exit, go back to my previous session. So I opened one session inside the other. Now I just went back to my former session. I am now going to use the export command. There. Okay, in this environment, it's there as it was before, but let's see in our shell, in our born shell, is it there? Yes, it is. If I exit, it's still there in my previous environment. So whenever we want to create a variable and make it available in any session that we have to export that variable right there. Okay, so now let's go back to our questions and move to question 2. Go to the bin directory and run a command stored in that directory. Do not rely on the path variable. You have to use relative or absolute path. Okay. I'm gonna go here. So it's telling me to move to the /bin directory. If I want to change the directory, I use the cd change directory command, space, and use a parameter, which is the directory I want to go to. If I use the pwd command, okay, I am in this /bin directory. How can I certify, how can I check whether, how can I run a command that is stored in this directory? However, the question says, do not rely on the path variable. Use relative or absolute commands. Now, what does that mean? We have to remember that when we type any commands, for example, ls, oops, too fast. So when I run any command, ls, I'm not informing where that file is stored in my file system. What is the system going to do? What is the Linux environment going to do? Actually, bash. What is the bash going to do? It is going to check if this command that I invoked is stored in one of the directories referenced by the path variable. Is it in one of these directories right here? This one, or this one, or this one, so forth, so on. Well, if I use the which command along with another command, the which command is going to tell me, okay, so according to the path variable, these are the possible directories to store commands, and I did find the ls command inside the bin directory. But again, when we invoke that command, we're just invoking the command name. We're not passing the location. Now, what the question is asking you to do is to run any command that is stored in the bin directory without relying on the path variable or on the which command. You have to use the full, you have to run any tool, any command that is stored in our current directory /bin, not using just the command name itself. Okay, so first of all, I can list, right, to see what are my options here. And I have so many options. Actually, the ls command itself is right here. Now, how can I run the ls command that is stored in my current directory without simply using ls? I have to use an absolute path or a relative path. When you want to use an absolute path, you have to start from the beginning according to the location where it is stored. So I know that the ls command is stored in this current directory, which is bin. So I could do /bin/ls. Here I'm invoking the ls tool and I'm using a absolute path. I'm going all the way back to the root directory, the / directory. Then I go to the bin subdirectory and here I have my ls. Okay, that's one option right there. Another option is using the relative path. The relative path is a path that you use according to where you are located. Since I am located in the /bin directory and the ls tool that I want to use is in my current directory, the current directory is referenced by the dot, just a single dot. / because it's a directory, ls. So let me go back there, /ls. So we have these two possibilities here, /ls if I am in the current directory where the file is stored, or the absolute path, which is /bin/ls. That's how we answer question 2. Now, let's go to question 3. The IP ADDR, which is short for address, you can also use address. The IP ADDR show command can be used to display your network interface's configuration. Create an empty file. Run the command mentioned above, but save the output in the ephase.txt file. Now rename this file to network.txt. Okay, so first of all, let's go back here. First of all, we have to use the IP ADDR show command. There. This is the output of this command. It's going to tell you what network interfaces your system has. So I have my loopback interface and I have my actual physical network interface. And you have some other information here, such as the IP address right here, the broadcast address, some other information, MAC address, some other stuff here, which is not important at this moment. We are going to have a class to discuss network configuration. That's not our focus right now. Okay, now, what it's asking us to do is to send this output to a file, which is the ifaces.txt file. However, before we redirect this output to the iface.txt file, we have to create that file with no content, empty content. I'm going to clear the screen here. If I want to create an empty file, I use the touch command. Touch ifaces.txt. Oh, I have to move back to my home directory. If I use the CD with the dash, just that option, dash, it's going to take me back to my home directory. Now I can create the file. If I check the content of that file, I'm going to see that it's actually empty. Another illustration about a file or files is the ls command with the -l option. There it is. And this is the file size, 0. Okay, it's empty. So now I have to redirect the output of the IP-addr show command to the ifaces.txt file. That's how we redirect it. It did not mention whether we should use redirection erasing a previous content, if there was any, or appending this new content to the former content. Well, it really doesn't make a difference in this situation because the ifaces.txt file so far is empty. So it really doesn't make a difference. You can either use this or this. Okay, let's see if it worked. Let's take a look at the file content. There it is. So I'm checking the content of that file. I can use the cat command, and yeah, the content is right there. Then it tells us to rename this file from ifaces.txt to network.txt. I'm going to clear the screen here. If I want to rename a file, I am going to use the mv command, move. It stands for move. mv ifaces.txt space network.txt. So the move command, which is similar to the ren command in a Windows environment, is the command that you use to rename a file. So when you rename a file, you're not actually renaming it. You are moving one file to another file, which at the end, you are removing the previous one, creating another one with the same content, or you're making a copy and removing the original one. So you're removing, at the end, you're renaming. So you use mv, the original name, space, the new name. That's how you rename a file. If I check my content here, there it is. My network.txt file is right there. Let's check the file content. There it is. Okay, good. Let's go back to our questions. Number 4. Display the content of the network.txt file. We've done it with the cat command. Replace all. There's a all missing there. Replace all occurrences of inet for IP address. So let's go back there. And here is the content of our file. Whenever I see this string here, inet, 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 I have to replace it for IP address. what is the command that we can use to replace strings? We can use the sed command. And the sed command is actually a tool that allows you to use what is called regular expressions. So regular expressions are the possibility of combining text, string, and symbols to represent a vast scope of possibilities. So in this case, I am going to use the S option, and you must first initiate with the single quotes. I am going to use the S option. The S option is used to say I want to substitute, replace, slash, and you inform what you want to substitute. I want to substitute inet by IP address, slash, and if I only wanted to substitute the first occurrence of inet, this is what I would do, like that. But that's not what I want. I want to replace all occurrences. So I use the /g space the file name. And there it is. Here, 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 and here. Now, observe that if I look at I'm going to clear the screen here. If I look at the content of the network.txt file, I still see inet there, inet. So the sed command by default does not replace the content of the file, only the output. Well, we know that we could simply redirect this to a file. It is important, though, to realize that I cannot use the same file name. It will erase this file. So you can redirect it to any file. Or we could also use the T command. Okay, so there it is. 5. Show the first 5 lines of the /etc/services file. Then show the last 10 lines of it. So we have this very large file here. The /etc/services. It's a very long file. It is so long that we're going to go back, we're going to move forward to the last question, which is how many lines do we have in this /etc/services file to count characters, words, and or lines. You can use the WC command. So if I do this, it's telling me that this file has 591 lines, 2,615 words, a little bit over 19 characters. If I want to specify, for example, that I only want to see the number of lines, I use the -L option. And I could also use -C for characters or -W for words. Okay, so there it is. You can see that it's a very long file, almost 600 lines. Now, if I use cat in this file, I'm going to see the entire content, and it's going to go all the way to the end. Nope, that's not what I want. I want to see the first 5 lines. If I want to see the first n number of lines, I can use the head command. If I don't specify the number of lines that I want to see, for example, if I do this, it's going to show the first 10 lines. That's the default, first 10 lines. If I don't want to see the first 10 lines, but in this case, for example, I want to see the first 5 lines, I use the -n option and then the number of lines that you want to see. So that's how you can see the first n number of lines. What if I want to see the last n number of lines? The last, not the first. We're going to use the tail. So we have the head and we have the tail commands. Since it's asking us to show the last 10 lines, which is the default, okay, now I can simply inform the file name as a parameter. What if I don't want to see only the last 10 lines? I want to see, for example, the last 20 lines. Well, you can use the -n parameter, just an option, just as when you're using the head command. Okay, so let's go back to our questions. So number 5, now number 6. Show the number 7, we've done it. How many lines? So we saw that it has almost 600 lines. And the last one, number 6, show the lines from this same file. We're still working on the same file, /etc/services, that contain the NTP string. So we have to filter this file searching for the lines that contain a specific string. And the command that we can use to do such is the grep command. So grep ntp/etc/services. Those are the only lines that contain the NTP string. Now observe that it will not necessarily display only the lines that begin with NTP. If I have these 3 letters together, it doesn't matter where they are. For example, here, they're not even a word. They're just part of a word. They are a substring. Okay, that counts. So the grep command can be used to do that. Now, it is very important to keep in mind and to remember that we have the pipe symbol. And the pipe symbol it allows you to build very powerful sentences, very powerful tools by combining different tools, by combining different commands. The grep is a command that is very much used along with the pipe command. So another option of doing the same thing here would be, so let's say that instead of using grep directory, I would use cat. Then I would pass the content of this file as a input for the grep command, searching for the lines that contain the NTP string. There it is. And there is no limitation in regards to the number of pipes that you use. Okay, so we saw here how to use some commands to work on the work with environment variables. We saw the concept involved in using relative path and absolute path. And we learned some commands that we can use to filter strings, filter files, process files, replace strings and substrings, for example, using the sed command. How to see the first number of lines, first n number of lines, last n number of lines. So these are some very basic, but at the same time, very important commands that we have to know. Once again, you will have access to a cheat sheet with many different commands along with these ones that we saw in our video classes, in this lab class, in the previous videos, but also some additional commands that are important to know to take the CompTIA Linux Plus exam. I hope you enjoyed this class. Thank you very much. Welcome to our Module 3 lab class. Yeah, it's Module 3 and not 2. And here we have a few questions, a few exercises regarding user and group management, as well as password management. So let's start off with our first one, letter A, which asks, what is the difference between add user and user add? And this is more of a discussion question, especially because we're going to deploy and see the technical difference in one of the other questions. So, what is the difference between add user and user add? Well, basically, the difference is when you're creating a user, what the system actually needs to do is to register that new user into the user's database, which are actually two files, /etc/passwd and /etc/shadow. Those are the files that need to be edited. Now, by doing that, it doesn't mean that the user will have a home directory created. It does mean that the user will have a home directory defined, but not specifically created. That is the difference between add user and user add. When you create a user using user add, the user will be created, the group user will be created, but the home directory will not be created. There will be no default password, and neither you'll be asked to define a new password for that user. The files that are stored in the /etc/scout directory will not be copied to the user's home directory. Well, obviously because the user's home directory wasn't created. If you use add user, all that stuff will be there. So the creation script will ask you for stuff like the user's new password, some comments, some information about the user, if you want to define that information, such as first name, last name, home phone, whatever that is. It will create the user's home directory, copy the files that are stored in the /etc/scout directory to the user's default home directory. So that is the difference. Moving to letter B. What is the difference between su and su dash? Now, to answer this question, we're going to go to our system here. First of all, to understand what the su command does, which stands for super user. Now, the difference is, well, if I do su in the Ubuntu system, it's not going to work. So the reason being is, when you use the su command, you're saying, I want to now go from this user to this other user. But if you don't define a user that you want to become, meaning, I could do, let me just end this, I could do su space, let's say, new user. What is this password? It's the new user's password. There. Who am I? I'm new user. That's because I said here, I want to change user and become new user. Okay, but since you are a regular user, Linux, to use this other user's account, you have to know that user's password. Okay, it asked for the new user's password. I knew it, I informed it. Now I am new user. If I want to log out, go back to my Linux user, I can simply do exit or Ctrl-D. I am back to my Linux user. When I don't inform a user, I just do su. That means that I want to become the admin user. I want to become root. To become the root user, obviously, you have to know the root user's password, which doesn't exist. So, In the Ubuntu environment, in order to become the root user, you have to do sudo su. Then this is your user's, in this case, my Linux user password. Now I am root. Okay, now what is the difference between using su and using su dash? What's the difference there? The difference is the dash means that I not only want to become that user, but I want to load that user's environment, such as environment variables, environment configuration. For example, here, when I did su without the dash, I remained in my current directory, the directory I was at. When I do the dash, I'm going to go to the user's home directory. The environment variables that will be loaded are the environment variables that belong to the user that I'm becoming. When I don't use the dash, I'm accessing the system as that user, I'm logging in as that user, but I'm not loading that user's configuration. So that is the difference. Now, question letter C. Create one group. Create 3 users. Add these users to the group created. Define one of the users as the group admin. And there is one new thing here. So how do we create a group? Okay, I'm going to do group add new group 2, because I already have new group. I want to add those users that I'm going to create to this group. To create a user, we know that we can use add user. Now, since I already have 3 users, I don't have to create these 3 users. So let me just use Linux, new user 3. I can do user mod and do user by user, saying new group 2, Linux. Now my Linux user also belongs to this new group. I can do with the other user, new user and new user 3. I could also use the group mod command to add users to the group. What I'm doing here when I use user mod is I'm saying that this user is going to belong to that group. If I wanted to say I want this group to have that user, I could use the group mod command. But okay, that's what matters. Now, if I check the /etc/group file there, I can see that these 3 users belong to that group. What I need to do now is define a admin user as the group admin user. That is because a group can have an admin user. By default, a group's admin user is the root user, but I can add another one. It must be a user that belongs to the group. And the idea of having an admin user in a group is that I am allowing that other user, which is not the root user, I'm allowing that other user to perform administration tasks when it comes to group administration, such as add a user to another user to a group, remove a user from a group. How can I do that? I can use the gpasswd command with the -a option. So I can do g passwd-a, for example, Linux, and the group name is new group 2. There it is. Now, this Linux user can add users and remove users to and from this group. Moving forward, question letter D. Check if these users now belong to the group created in C. We check that. We looked at the /etc/group file. We can also use ID, right? And we can see that my user, so ID Linux, ID, what is the other user? New user and new user 3. All of them belong to that group. Letter E, create a fourth user using user add, but make sure that the home directory is created, a comment about the user is recorded, and the skeleton files are copied to the user's home directory. So, we know that when we use add user to create a new user, all that is going to be done. But what about when I use user add? Nope. So I have to inform all that. First of all, so I want to do user add and the new user, which is going to be, let's say, new user 5. Now, we need those options. To insert a comment, -c, user 5, for example. To define a base directory, we need -b. To use a specific directory as the skeleton directory, -k. We also have to define the home directory with the -d, and those are the options that are actually required along with the -m option. -d /etc /home /new user 5 /m. Oh, right. I forgot to inform. And there it is. If we look at the /home directory, we're going to see new user 5 right there. What if I look at the /home /new user 5? Oh, so the files that are stored in this /etc/scale directory are now there. Okay. Moving to the next question, we have explain and show the difference between system and regular users. So let's remember that. If we take a look at the /etc/passwd files, we can see that the regular users have identification number beginning starting at 1000. There it is. Below 1000, it's system users. Another difference that we can see is when we take a look at the /etc/shadow file, we can see that regular users, they have a password there, hashed password, and the system users have a asterisk at the instead of the hashed password. That means that this user does not have a password that's been defined. So that's how you can differentiate those two different types of accounts. System accounts. The account ID is below 1,000, and the regular user account is from 1,000 plus. Now again, it depends on the system. There are some systems, especially older systems, that the regular user accounts would begin in 500. Okay. Letter M. And I have to fix these identifications here. Define the same password to two different users. Show their hashed passwords. Are these hashes the same? Why? So the question is, let me define the same password for a new user. I am going to define password. Password. And the same password to new user 3. Password. Password. Let's take a look at the hashed password, which is stored in the /etc/shadow file. New user and new user 3. Let's take a look at the hashed password, which goes from here to here, from here to here. We can see that they are completely different. Now, if we were using encryption and we had the same key, the result would be the same. This is not the case. When we have a hash, it doesn't matter if the plain text is the same, the hash will always be different, unless we use the same hash to generate that password, which is not the case. So the hash is right here, DSX7, and the other hash is GM60. So different salts, these are salts, I said hash, but salt. So different salts will generate different hashes, even though the password is the same. So the reason for that is because the hash is generated based on a randomly generated value called salt. Let's go back to our questions. The next one, lock a user's account. Well, there are several different ways of doing it, but let's do it using the passwd command with the -L option. New user. Okay, so it's locked. We could also do the same using user mod with the -L option. And you can also do the same thing using the change_age command. So there are different ways of locking a user's account. Letter O, define a user's password expiration date. Okay, how do we do that? There it is. Expiration date. -E. So you can use change_age space -E space the date space the user. And finally, prevent a user from logging in. Don't lock the account. So, if I try to log in with the new user, which one was it? Is this the one? Yes, that's the one. Let me just make sure. Okay, so if I try to log in with new user, I can't, but that's because I locked its password. Let me unlock it. There, I can log in with that user. Perfect. How can I lock this user account but not using, how can I prevent the user from logging in but not locking its password? Well, one way of doing it, if we may remember, is editing the /etc/passwd file. And here's the user. I can change this to /usr/sbin/no-login, just as the same configuration that we have here for our system users. Or if you don't want to edit the /etc/passwd file, you can use usermod. So in the usermod, with the usermod command, we can here, new login shell for the user account. This is the option that we have to use to define the command or tool that will be executed when the user logs in. So if I do usermod -s / let's use another one, /bin/false for the new user. Now, su-new user, the password, which is password, no directory, logging in with home, but, well, apparently I was able to log in with that user, new user. But if I do, who am I? No, I'm still Linux. I'm not that user. Why? Because the authentication process did work. But after I authenticated, that shell was executed, which is a invalid shell. /bin/false doesn't exist. I could do the same thing with /usr/sbin/no-login. The user would be automatically logged out. So there is one way of preventing a user from logging into the system. There it is. So we had these about 10 exercises, which are some exercises that required us to work with some commands to create users, change users configuration, create groups, define groups configuration. Also, we had to deal with users' passwords and check their environments. I hope you enjoyed this class. Thank you very much. Hi, welcome to our Module 4 lab class. And our goal here is to review what we learned regarding permissions and ownerships. So we have these questions here from A to F. So we have 6 questions where we're gonna be introduced to a scenario, and we have to do whatever is being asked regarding that scenario. So let's take a look at the scenario that we have right here. A company has 3 departments, among other departments. So these departments are development, HR, and IS, information systems, with at least 3 employees in each department. Okay, so we need 3 different groups and 9 different users or user accounts, where each department will have 3 of those 9 accounts. A new server has arrived, and the structure of directories and files must be created according to the following. So there is a new server, and this is what we have to do. Letter A. Each department must have a directory in the root directory, in the / directory. It's not the /root, it's in the / directory. So each department must have a directory there. The departments are development, HR, and IS. Okay, so let's go there. To create a directory, we use the mkdir command, mkdir space the directory you're willing to create. So first we're going to create /development. Then we have to create the /HR directory, and finally the /IS, and I'm going to use capital letters here. It's important to remember that in a Linux environment, capital, uppercase and lowercase characters are different characters. If I list the content of the / directory, I can see the development, HR, and IS directories right there. Okay, let's go back. Each department must have a group. Okay, so let's go back. That means that we have to create a group for each of those departments. So group add development, HR, IS. If we take a look at the /etc/group file, there they are with their corresponding IDs, GIDs. Okay, that's done. So it's the group add command that we need to use. Then we move to question letter C. Each employee must have an account and belong to the proper group. It does not mention that the user must have that specific group as its primary group, which means I can create, let's say, the user dev A. It doesn't mean that the dev A user must have the development group as its primary group. So I am going to create user dev1, for example, which is one of the developers. Define a password if you want to answer all that. There. Now, if I take a look at the dev1 user, its primary group is the dev group. I don't have to change this. I simply have to add this user to the development group. How do I do it? I can use the user mod command with the -g option. Dev1. Is that it? Let's is it development? I can't remember. So oh, it's development. There. Now let's check the information about user dev1. So its primary group remains dev1, but now that user also belongs to the development group 1001. Okay, so let's go back there, and each employee must have an account and belong to the proper group. So we have to do that to all of our 9 users. I'm going to do it quickly. We saw how to do it step by step for the dev1 user. I'm going to make it a little bit quicker with the other users. So add user dev2. There it is. dev3, hr1, hr2, hr3, is1, is2, and is3. Now I have to include them in the corresponding group. User mod -g development dev2, dev3, hr1, hr2, hr3, and finally is1, is2, is3. If I take a look at this /etc/group directory, we can see that dev1, dev2, and dev3, these users, they belong to the development group. hr1, hr2, hr3 belong to hr, and is1, is2, is3 belong to is. Okay. So, letter C is done. Letter D. Files can only be created in these directories by users that belong to the corresponding group. However, files can only be removed by the owner. If it says files can only be created in these directories by users that belong to the corresponding group, that means that I have to set permission to the directory. Obviously, we have to remember that the write permission, which means creating or removing files from a directory, is defined by setting those permissions on the directory, not on the files themselves. So, we have to say, first of all, let's take a look at the permissions that we have there. So the development directory belongs to user root and group root. Well, we have to change that. We don't have to change the owner, but we have to change the group. The group must belong to, the group owner must be the development group. Same thing for the other directories. We have to change this to hr right here, and we have to change this to is. How do we do that? We use the chown command. Since we're only changing the group that owns the directory or those directories, we don't have to define the user. So we simply do dot or column, it's up to you. I'd rather use dot. So dot development / development. Same thing with the other directories, hr for the /hr and is for the is directory. There it is. So now we have this group here, we have this group, and we have this group owning those directories. Now what we have to do is set these permissions. So if I want to say that only users that belong to this group or this group or this group will be able to create and remove files from those groups, we have to give write permission to the group that owns the directory or the directories. So G plus write development HR and /is. There it is. Okay, now we actually have to test. So let's go back to see if we've done what we have to do. Files can only be created in these directories by users that belong to the corresponding group. However, files can only be removed by the owner. Oh, so there's something else that we have to do here. How can we guarantee that? So first of all, let's do the first test. If I log in with my dev1 user. Okay, so I'm user dev1. If I try to create a file in this /development called dev1.txt, okay, I was able to. There it is. I'm the owner, and that's the group that owns the file. Observe that I didn't say, there is nothing mentioning that these files that are created inside those directories have to belong to the same group that owns the directory. It doesn't mention that. It only says that only users that belong to the group that owns the directory can be able to create a file. Okay, so let me first test that before we test the deletion. Since that's what it says, that means that if I, as the dev1 user, if I try to create a file in the /is directory, I am not supposed to be able to. Okay, which is correct. That's working. Very good. Now, it also says that if I try to, I'm still dev1. Let me go to the dev2 user. And I'm going to, as the dev2 user, I'm going to create the /development /dev2.txt file. There. What it says is, okay, both users, dev1 and dev2, they belong to the same group. So, development, they should be able to create files in the /development directory. And yes, that's what we have there. Now, what is not supposed to happen is dev2, for example, that is the user that I have right now, is not supposed to remove a file that belongs to someone else in that directory. So if I, as dev2, try to remove the development /dev1.txt file, oh, wait, it worked. I'm not supposed to do that. So how can we guarantee that a user won't be allowed to remove a file that does not belong to him or herself? That's where the sticky bit comes in. So I'm going to go back to my dev1 user. I'm going to create that file once again. Oops, not this one. This one. And I'm going to log in with my dev2. Oh, no, but not yet. So first let's set the sticky bit. chmod +T to the /development directory. Oh, that's not the proper user. Okay. chmod +T /development. Now, if we take a look at the permissions that we have there, now the sticky bit has been defined. So let me log as the dev2 user. And let me try once again to remove that file. Now I can't. It's the sticky bit that forced that prevents that user from doing that operation. If that user tries to remove the file that belongs to himself or herself, then it should work. There it is. Now that's what we have in the /development directory. Only the dev1.txt file that belongs to the dev1 user. Moving forward, letter E. Make sure that files created in the directories belong to the appropriate department group. Now, we have to make sure that this does not happen. This does not happen. Since development is the group that owns the directory /development, this must also be the group that owns any file created inside that directory. How do we do that? How do we force that? We have the sgid. So let me go back to the Linux user. That's the user that has permissions to do administrative tasks. And I'm going to do the G+S on the development directory. Obviously, all these tasks, they have to be performed over all the directories, not only development, but also development, HR, and IS. I am just showing all these steps on the /development directory because it's all the same. Okay, now let's take a look at the /development directory, and now I can see the sgid bit is set. Let me log as dev1. It could be dev2, dev3, whomever. It doesn't really matter. I just have to test by creating another file in the /development, and this one is going to be called dev1sgid.txt. Okay, I created it. Let's see the permissions. Oh, there it goes. Development owns the directory. The files that are created there should also belong to that same group. Now, you may ask, why is this file Why does this file still belong to the dev1 group? Well, because it was created before the sgid bit was set. If that's the case, then you do have to do a chown and redefine the group that owns the files stored in there, that were previously stored in there. And finally, we have letter F. Users belonging to the department must have read, write, and execution permissions to the files stored in the department's directory. Wait, this seems to be something new. It says here that we have to define the permissions that users will have when files are created. It's not about ownership, it's about permissions. Users belonging to the department must have read, write, and execution permission to the files stored in the department's directory. This is called UMask. The UMask right there, is the command that will allow you to define the mode, the permissions that will be set up, defined on files when files are created in a specific location for a specific user or group. Now let's see how the umask works. You have to consider that you have the decimal values that you can use in order to define permissions. Let's take a look at the current configuration, the current umask configuration. If I create a file here, and I'll just test, test.txt. The permissions are read, write, in decimal, that corresponds to 6. Then I have, oops, I'm sorry, it's this one. Read, write, which corresponds to 6. Group, read, write, which also corresponds to 6. And then I have read, which corresponds to 4. If we do this, 6, 6, 4 minus 0, 0, 2, then we have the permission that we want to define. But actually, the computation must be 666 minus the umask, which is 002. If we do this calculation, the result is going to be 664. That is why whenever I create a new file, those are the permissions that I will have. So in order to calculate the umask, you have to take 666, which is full permission for regular files, not directories. Read, write, read, write, read, write. Because for regular files, you don't want to define regular files as executable files. So you only consider read and write permissions. Minus the umask, and then you have the resulting permissions. Which means that you'd have to do 666 minus the permissions that you want. In this case, if you want read and write for the owner, read and write for the group, and read for others, you're going to have the umask that you have to define. However, observe that the umask is defined for a user. It's not defined for a group. It's not defined for a specific directory or file. I can change my user's umask to, let's say, 022. There it is. Now, if I create a file here, test2.txt, oops, there. Observe that I removed the write permission to the group. Well, that's not what I want. Users belonging to the department must have read, write, and execution permissions to the files stored in the department directory. Well, actually, we can't define umask including the permission of execution, but that is valid for directories. Whenever we set this type of umask here, it will define the permission of execution to directories. So after all, what we need to do is to define a umask where the users that belong to a group that owns a directory will have write and read permission on files that are created in that directory. Well, it is actually already defined like that. So I am the dev1 user. If we take a look at the way that the files are created, the permissions that the files have in the /development directory, that's what we have right there, actually over here. So all users that belong to development will have read and write permission on files that are created in there. What if I create a subdirectory there? For example, dev1 now as a directory. Okay, I cleared the screen here. So let's take a look at the dev directory that I created there. Observe that I don't have the write permission there. That is because my umask has been redefined to 022. So let me bring it back to 002. And I'm going to create the dev1 new. Now, there it is. So, and it's also important to realize that the sgid bit has been set to that directory. So that's what we have to do. We have to make sure that whomever creates a file inside the department's folder, the users that belong to that same department must have read and write permission. So that is actually the default. But we have to understand that the umask file does exist, the umask tool does exist, and sometimes you have to use it. Now, one problem that we have is that the umask command is actually defined while logging in or while opening a shell, which means that if I redefine, so let me change my umask back to 022. There. By default, it's 002. I'm going to log out and let me go back. Let me check my umask. Oh wait, it's 002. It's not the one that I defined before I logged out, 022. That is because the umask is set when we open a new shell. So what we have to do is we have to remember that we have two main files, /etc/profile and the /etc/bash.bashrc. Those are two files that will have configuration defined to all users. If you want to define some other stuff for specific users, you have similar files in their home directory. For example, for my user, dev1, I have this user's home directory, dev1, and in there we'll have the dot profile and the dot bash rc file. Any command that we put in those files will be executed when these users open a new session or open a new terminal. If you want to, let's say, define a umask to all users, then you can place the umask command inside the. So what you can do is, I have to be the Linux user here. So what I could do would be edit the /etc/profile file. And here I could go to the last line and do umask 002 or whatever it is, 022. And I save this file. Now again, you have to know how to work with a text editor in a Linux environment. A cheat sheet will be placed for you, will be made available for you, so you can get used to the VI editor. If you want to make some specific configuration for a specific user, let's say I want to define a UMask, but a different UMask for my dev1 user. So I added this /home/dev1 / for example, bashrc, and do it there. So keep in mind that you have to define a UMask in one of those files so that that UMask is actually there whenever the user logs in. Okay, so that's how we solve those questions. And in this lab, we were able to work with ch-on, chmod, UMask commands, as well as the commands that we learned in our previous class, which are the commands to create users, create groups. Thank you very much. Okay, welcome to our lab class, our Module 5 lab class. And here it is quite a quick lab. We just have from exercises from letter A through F, and they're pretty straightforward. Okay, so let's take a look at it. Letter A, create a second virtual hard drive attached to your Ubuntu virtual machine. Well, probably you already have it if you followed the steps that were introduced in our previous video, in our Module 5 Lecture 2 video. You already have it. If you don't, please do. Then you create one single partition matching the size of the entire disk. Okay, so let me go there. Here I am. Just to recap what we did in our previous video, our previous lecture, I created the /dev/sdb drive, and then we partitioned it into two partitions, SDB1, SDB2. SDB1 was created to be a file system to store files. SDB2 was created to become a swap partition. But for this exercise, we are not going to use these two partitions, which means that first I have to remove these two and then create what is being asked. So how do I manage partitions? Sudo fdisk/dev/sdb, letter P to print the partition table. Okay, so we have those two partitions and I want to remove them to then create the other ones or the other one. If I enter M here, I'm going to see that letter D is actually the option that I have to use in order to delete a partition. So that's what I'm going to do. I'm going to enter letter D. Which of those two partitions do I want to remove? Actually, I want to remove two, but we cannot remove them all at once. So I'm going to pick partition 1 first. Now letter D once again to delete the other one. Actually, since that was the only partition, I didn't have to inform the partition number. That was the only one. So it's been deleted. I can print it and I can see that the drive doesn't have any partitions anymore. Now I can do what's being asked. So let me go back, and it's asking us to create one single partition matching the size of the entire disk. Okay, so letter N to create a new partition. Type, I'm going to pick as primary. Partition number, I'll just pick 1. It's going to be number 1. What is the first sector? I'm going to just hit enter because I want to use the very first sector that is available. And what is the last sector? Since I have to create a partition that covers my entire disk, I have to make it all the way to the very last sector, which is the default. So I'm going to simply hit enter here as well. It says that partition contains a ext4 signature, which is perfectly fine. That's because I formatted that partition previously. So do you want to remove this signature? Yes, I do. Now let's see. Okay, now I have only one partition, SDB1, and its size is 1 gig. Oh, that's good. So it's using my entire disk. I can write those changes, save those changes, and there it is. So now if I do fdisk dash L slash dev slash SDB, there it is. I have only one partition, it's saved, it's done. Then we have to format that partition. Well, it's not specifying the file system. So what do? I'm going to use mkfs/t, and just to change it a little bit, I'm going to define it as x3/dev/sdb1. There it is. I formatted it. Mount it using /data as a mount point. Now, the first thing that we have to be sure is, does the mount point exist? No, it doesn't. No such file or directory. So first, I have to create the mount point, and mount points are directories. So I have to create a directory using the mkdir command. Now, I can mount /dev/sdb1 on /data. Oops. And I forgot the mount command. There it is. Has it been mounted? Let's see. Oh, there it is. I can use the df command, or I can use the mount command. Yep. Okay, so /dev/sdb1 is mounted on /data, and it's a x3 file system type. Okay, good. Configure fstab to mount the partition during the boot process. So that involves this /etc/fstab file. Okay. Now I have to edit the /etc/fstab file. Since I don't have these two partitions here anymore, I'm going to remove this one, and I'm going to simply change this one according to my new configuration. Oops. Data, it's not x4, it's x3, and I can just leave the other options there. Okay, good. Now I save it, and it says reboot your Linux system. Confirm the recently created partition is accessible. Now, let's see something here. Oh, first of all, let me umount /data. Okay, so /data is not mount, /dev/sdb1 is not mounted on /data anymore. Instead of rebooting my system, I'm going to do mount -a. Mount with the -a option. Now, if I list my mount points and my accessible devices or partitions, it's listed there. What did I do? When we use the mount with the -a option, you are forcing the Linux system to read again the /etc/fstab file, which means that I don't actually have to reboot my system. The /etc/fstab file is read by the system during the boot process. But if I want to force my system to reread that file, I can simply use the -A option. And to confirm whether it's being mounted or not, I can use df or mount, and there it is. If I use mount, I can see the file system, x3. Okay, so if you want to reboot your system to confirm it, you can, but you don't have to. You can simply use mount space -A. It's the same result. And confirm the recently created partition is accessible mounted. Yes, it is. We can see it right here. I hope you enjoyed this lab class. Thank you very much. Hello, welcome to our second video of Module 8, and the goal here is to see how the booting process actually works in the Linux environment. So in order to see that happening, the first thing that we're going to do is actually reboot our system. We want to follow the entire process. So I'm going to go here and restart my machine. Now, it will happen very fast, so keep in mind that in order to see the bootloader, whether it's Lilo or Grub, you have to hit the Shift key. It will actually depend on your system, on your hardware, but most of the times it's going to be the Shift key. Sometimes it may be ESC, but it's one of those two. So I'm going to click on Restart and just keep pressing Shift. There. Now, the reason why I'm pressing Shift is because if I don't, it would automatically pick the very first option or the default option in my bootloader, and it would not display the options for me. It would just automatically boot the default operating system listed or configured in my bootloader. So what that means is, let's say that I had two operating systems installed, Ubuntu and Windows. Well, if Ubuntu is the default OS and I don't hit the Shift key, it would just boot the Ubuntu system and I would not see these options that we can see right here, which means that I wouldn't be able to boot the Windows operating system if that's the case. Now, we discussed in the last video that we have mainly two bootloaders in the Linux world, Lilo and Grub, and basically Grub is just the evolution of Lilo. Lilo had quite a few limitations in regards to performance, in regards to what it could do from here. So as you can see, here I can, for example, so I have the options. When I install a Ubuntu system, I will have the option of booting on my operating system. I can also go to the advanced options for Ubuntu in case I want to change a few configuration of how my Ubuntu system is going to be loaded. And I have also some memory test tiny softwares here. If I had Windows, I would also have another fifth option here. So first of all, in case in the Ubuntu world, in the Grub world, I can, for example, let's say that I want to check the configuration of how my Ubuntu system is going to be loaded. I bring my cursor to the system that I want to check, in this case Ubuntu, and I press letter E as in edit. There. So those are all the configuration that you have in order to boot, to initiate this operating system. Now, there is a bunch of options here, a bunch of configuration, a bunch of parameters. But what is most important here is these last two lines. Linux, so the Linux parameter right here, it tells us, it points out to the kernel. So this is the kernel that should be loaded. And I also mentioned that we have the initial RAM disk, or init-rd, which is identified right here. So this is how we define the kernel that the grub is supposed to load in order to initiate my Ubuntu system. But also, in case there are drivers that are not built in case I have modularized drivers or modules, they should be loaded in, they should be contained in this file right here. This file should be loaded as well. So the booting process to load the kernel and to initiate the devices, the hardware devices that I need, actually I don't only need this one file, the kernel, but I also need this one. In regards to the CompTIA Linux Plus exam, you don't have to know how to configure grub, neither Lilo. You don't have to know how to do that. You just have to understand how it works. But I think it's good, very good to actually know how it works. Now, one of the advantages of grub is that I can actually change any of these options here in case I want to. Obviously, we're not going to go through this, but that is possible. Okay, so I'm going to load this system here. The kernel is being loaded. The drivers are being loaded. The initial process, the very first process, has been loaded, and that very first process invoked many other softwares, which, at least for now, we were not able to see. Okay, but the system is there. Let me log in. And we're actually going to analyze what happened. And there is a very good tool or log file that we can use to take a look at that. So I'm going to go here, open my terminal. As usual, keeping in mind that in the Linux world, we're always focusing on the command line interface. Okay, so there is a command called dmask. And I'm going to hit a pipe more here because there's so much information there. And what the dmask is going to do is it will show you everything that happened when the Linux operating system was invoked, when the kernel was loaded into the RAM. So, first of all, first information that we can see here, there. My kernel is being invoked right here by booting, by loading this file here, and then it starts, so the kernel starts detecting the hardware that I have. So that's my CPU, and then it will just detect how much RAM I have. So all hardware that I have must be loaded during boot time. Now, some of these hardware parts, components, maybe they won't be properly identified by the kernel. That's where the initial RAM disk comes in. But anyways, all those device parts will be loaded, and the proper drivers should be loaded. So we can see here information about my CPU, ACPI, and we just saw the RAM disk right there. So If we scroll down, we're going to see so many other peripherals and components being loaded here. There you go. There you go. Starting to load my PCI devices. So I have my PCI buses. And it's trying to detect the type of hardware that I have until it's capable of doing it. So now it's also detecting my USB ports, net label being initialized, my VGA, there. So all these device parts are being loaded. Now, once it's capable of detecting according to the registers instructions, interruptions, it's able to detect the model of those device parts, device components that I have, then the proper drivers are going to be loaded until I have my, there you go, my hard disk now being accessible. Same thing for my network device, my graphical interface. They will all be loaded by the end of this process. There. It's detecting also my CD-ROM drive. So USB ports. Now, since it first detected that there is a network interface and it was able to detect the network interface model, now it's loading the specific driver. So it happens to all my devices and it goes all the way down. There. So that is a description of what's going on during the process of loading the kernel, loading the modules, loading the proper drivers, and making those hardware components available. Once this part is done, once all the drivers are detected, then we're going to have our very first process being loaded. One way of seeing that is using the ps space aux command. And I'm going to pipe more here just to stop at the very first page. Now, here, PID 1. And we have a init process right there. Now, look, although it shows as a init command, it's not actually the init command. So if I do ls-l sbin init, we can see that it's actually pointing out to the /lib/systemd/systemd file. So this is the initial process, initial system that I have running in my Ubuntu 18.04. Then this system will load those other bunch of processes, software. So if we go back to the list of processes that we have running here, there. Okay, then we're going to have this, we're going to have this. All those other softwares are now being loaded. According to what? According to my run level. Now, how can I define my run level? And there it is. In order to define the run level and also the softwares that will be associated with each specific run level, you can use the systemctl command or system control command. There are some different setups for this tool right here. If you want to define the default run level, you simply have to do systemctl set default set-default run level and the run level number dot target. So let's say that I want to change it to, for example, 1. There it is. Now, it removed the previous run level, which was 2, and now it defined a new one, which is 1. But that's not what I want. I just wanted to show you that that is how you do it. So let me bring it back to run level 2. Okay, now once you're running, you have your run level, the run level that you want to run by default. Once you have the system loaded and running in that run level, you can define the tools according to that run level. You're also going to use the systemctl command to do so. So if you simply do systemctl, and let me do a pipe more here, it is actually going to show you all the softwares that you can configure to load during the booting process. There you go. They're all there. If you want to enable or disable a specific software, you're going to do systemctl enable, let's say cups. That's the printing system. And there you go. Synchronizing state of cups.service with systemv, service script with /lib/systemd/ there you go. And executing that service. Now it's enabled. Now there is a difference between enabling a service and starting a service. When you enable a service, you're saying, I want to load this software when my system boots. But if the software is currently not running, you have to start that software. So you can use start, stop, you can restart, you can use these instructions according to what you want to do. And obviously there is a bunch of other combinations that you can use, and you can see using the systemctl --help. Let me do a pipe more here. So many options that you have available in order to adjust, configure how you want to define the softwares that should be loaded during boot time or not. So that is how the Linux operating system is booted, how the softwares are loaded. That's how you can configure the run level and also the software that should be loaded according to the run level that you have enabled. I hope you enjoyed this class. Thank you very much. Hi, welcome to our module 9, and our goal here is to understand the system, some of the system components. We saw in our previous module, module 8, we saw how the Linux operating system behaves during the booting process. So we learned how the kernel is loaded, how the drivers or modules are also loaded to the memory, and then we have the initial process, the process 1 being invoked by the kernel. And we must remember that we have three main initialization processes. We can have the systemv, or also called init. We can have upstart, and we can also have systemd. Now, once this initialization process is invoked, it will then invoke other processes, which makes us wonder, how does the operating system manages processes, and how can we manage processes as well? So our focus in this class is actually going to be how to analyze processes in the Linux operating system. Therefore, the first tool, the first command that we have to talk about is ps, or short for processes. If you simply run ps, it will only show the process ID, so each process has a unique process identification number, or PID. It will show the process PID, but only for the processes that you are currently running, you are currently using. In this case, I'm using my console, I'm using the bash, and I use the PS tool to list the processes. So basically, I can only see two processes, bash and PS. And here are their PIDs. Now, these processes, they are associated, they're linked to a specific terminal, to a specific console. That is why we only see these two, because it will only list the processes that are associated with my current terminal. For how long they've been running, and we'll also talk about what a running process actually means. And then we have the command that is taking care of that process. Now, what if I want to see some more information? What if I want to see more details about these processes? Well, I can use the -L option along with the PS command. It will show me some other information. For example, the user that's invoked that process. Once again, the PID. Now, we learned that processes, they actually have a parent. So in this case, this process 1752, which corresponds to my terminal, to the bash, is actually child to this other process over here, 1653. So there is always a child-parent relationship. We have to remember that the init or systemd or upstart are the processes that will have number 1. All the others are children to this process number 1. And obviously there is a hierarchy there. So for example here, we cannot tell whether process 1653 is child to process 1, but we only know that 1752 is child to 1653. Then we have some other information, and what is important here that we'll also discuss is nice. Now, there is a difference between priority and nice. The priority will determine how much different instances of the CPU that process will take care. It does not actually define what we understand as a priority. What we understand as a priority, which is which of the processes will be executed first, or will have more resources available, or will have resources available more quickly, is actually defined by the nice information. So nice actually tells whether the process defines whether the process is supposed to be nice or not, is supposed to be polite or unpolite. We can analyze it that way. What it means is when we're defining priorities to processes, we cannot think of actually defining priorities. We have to think of defining which processes will cut the line, which processes will be unpolite. That means that defining the priority will require you to specify a number, and as lower as that number is, the higher priority that process will have. The higher values for nice will define that process will go to the end of the line actually. But we'll talk more about that when we see the nice and renice commands. And then we have some other information. Now, we also have time here. But before we see that, let's take a look at this other information here. These other options belonging to the PS command, AUX. AUX is because you want to see all the processes belonging along with the user that owns that process and the command that invokes that process. Okay, now, to better understand Let me do a pipe more here. Oops. Pipe more. Now, to better understand time, observe here that there is a difference between start and time. Start does mean the moment at when that process was actually initiated. Now, time means for how long this process has been running. And to understand that, we have to understand the status of a process. Processes may have many different status. You can have a process in the sleeping status. That's what the S stands for. You can have a process that's been stopped, letter T. You can have a process that is running, letter R. You can have a zombie process, letter Z. So you have different states. The most important ones are stopped, running, and sleeping. Well, stopped seems pretty straightforward. You had a process that was running or sleeping, and then you are no longer allowing the CPU to do anything to that process. So the process is stopped. There is nothing going on. You haven't finalized, you didn't kill the process. It's still there. It's still in the RAM, but it's not processing anything. It's not allowed to process. Now, the difference between sleeping and running. A process, when you have a software that's open, it can be either sleeping or running. If at that specific moment that process or that software is not actually demanding CPU computation, it's just sleeping. For example, let's say that you have a web server. You have the Apache web server running, and there are no clients requesting web pages from that server. You can have clients that are connected. They have established a connection, but they're not, at that specific moment, they are not requesting anything. You are going to have a process that is stopped, that is sleeping. Now, at the moment that the client actually requests the web page and the web pages are being transmitted to that client, then that process changes to the running state. So running state is every time that a process is actually requiring CPU computation. So it's running. That is why most of the times you're going to see, as you can see here, that all the times are 0. That's because those processes are actually running, so they are under execution. They're just not demanding CPU computation, as we can see right there, except for snapd right here. So it's not snapd has been demanding CPU computation for the past 2 seconds. Maybe if I run the command again, it will be 0. There. And there was another one here, which was the GSD caller. The shell right here, so the GNOME shell has been actually running for quite some time, 50 seconds. So that's what time means. Now, another very interesting process status is zombie. It's not very common, but sometimes you may see a process with letter Z instead of S, R, T, I. You can see Z. Z stands for zombie. What's going on when we have a process in the zombie state? There is absolutely nothing going on. And we have to understand the difference between a stopped process and a zombie process. A process that is stopped, it is actually using RAM because it is in the memory. The software is loaded. It's open. It's just not doing anything, but it's there. It's different from when you close a process, you close a software, but for some reason, for some bug, for any reason, any particular reason, it will be listed in the list of processes. That software is not in the RAM anymore. It's not occupying space. There is no memory being allocated to that software, but it's just in the list of processes. So you don't have to worry if you see a zombie process. Don't worry, it's not doing anything. Now, in case you want to see the list of processes, but analyzing the hierarchy, the interdependence, the hierarchical interdependence between all the processes, you can use the ps3 command. So let's take a look at it. Let me clear here, go back. So simply run ps3. There. So we can see that systemd is the main process. That's the init process, the first process. And below this process, we have network manager, all these ones. Now, under GDM3, we have so many others. Obviously, this is not the most friendly representation, graphical representation, but that is because I am using a terminal here, and I changed the font size. So it's not very accurate. Well, it's accurate, but it's not representing well. But you can see, well, you could even, to make it better, you could stretch the window. But since you're going to use it in the terminal, in the actual console, you're not going to have this problem. So you can see the interdependence among the processes. Here, for example, I have systemd. Below, under systemd, I have AT, another AT, dbus. So you can see how it goes. There. Under GNOME terminal, I have this ps3. And there it is. Now, I mentioned in the past that everything that happens in the Linux operating system is actually a file. Everything, absolutely everything. I even mentioned that even softwares, processes that are running are files. Proof of that is that if you list the /proc directory, you're going to see files or directories representing all those processes that we can see when we run the ps -aux command. So all these processes here, they have files associated to them in the /proc directory right here, there, according to their numbers. But now, how can we change the status of these processes? How can we change their signals or send signals to them? We talked about the different states of a process, such as running, sleeping, stopped. But we're supposed to have a way of actually redefining those status or those states. Well, it's actually pretty simple. First of all, we have to understand the different types of states that we have. And we can take a look at those states by using the kill with the -L option. There it is. So these are the different types of states that we have. If you want to take a look at more details about these states or these signals, actually these are signals, you can take a look at the man page for the kill command. Or you can also take a look at the man page for signals. There. And here you're going to have a description of those signals, such as term, ignore, core, stop, continue, so many other ones. Okay, so there it is. Observe here that each signal has a number. For example, if we want to interrupt a signal, we can use sigint or number 2. We can use, for example, and this is mostly used, either sigkill or sigterm. These are the two signals that mostly you're going to use in order to stop a software, stop a process. Well, not actually stop, but kill a process. And there is a difference between sigkill and sigterm. The difference is sigkill will, it doesn't matter what that process is doing, whether it's interacting with the CPU, whether the CPU is computing something associated with that process. And the sigterm is a little bit different, because if that process is interacting with the CPU at that specific moment, the system will wait for that computation. Once it's done, then the process will be terminated. And you have some other types, for example, sigstop, number 19, and sigcont. Okay, so let's take a look at the how to change the status of a process. So not this one. There. Okay, so this is a tool you can just install at any moment. It's not installed by default. It's called xsysinfo. It will basically display some load information about your system there. The reason why I decided to use this one is because you can see that it is actually doing something at this very moment. So as the system is loading, processing something, it will show. So it shows the load average, the average load actually, the load, the current load at that moment, the amount of memory being used, and the swap. Okay, what matters to us is this one, load, because this is the one that is currently changing all the time, because it takes the load at that specific time. Okay, so I have this process running. Observe here that when I run a tool, there is a chance that tool, until that tool is done, is finished, until it's finished doing whatever it's supposed to do, it will lock the terminal. See, I can't do anything here. It's locked. My console is locked. Well, many times I have to do this. I have to invoke a software that will just keep running. But obviously, I don't want that software to lock my terminal. There are some different ways of solving this problem. First of all, I have that software running and locking the terminal. I can do Ctrl-Z. I hit Ctrl and the letter Z. You see that it's stopped? If we take a look at the processes, there. Oh, there it is. So it is stopped. And if we observe here, look, the load is not changing. I can move the cursor, I can do whatever. It's not changing because the process is stopped. Now, how can I see the process that I stopped? I can use the jobs command or jobs with the -L option, which will list the PID. Okay, so xsysinfo is in the stopped status, stopped state, and it's identified by number 1. That's not the PID. The PID is here, but it's identified by a specific number. And that number is ordered according to the number of processes that I bring to my foreground, background, depending on what I do. Now, what is the difference between foreground and background that I just mentioned? A process in the foreground is a process that will actually lock my terminal. So if I just bring %1, so I use the percentage and the identification here, not the PID, but just this identification, this local identification, it will bring this process back to the foreground. And now we can see that it's running again. There you go. But again, my terminal is locked. Well, what can I do? I'm gonna do Ctrl Z once again. It's stopped. Now I'm going to continue it again, but I'm going to send it to the background BG. There, it's running once again. If I list my processes, it's running, right? However, my terminal is not locked. So that's the difference between running a process in the foreground and in the background. In case I want to stop that process that is running in the background, what can I do? So if I had this process running in the foreground, like here, I could simply hit Ctrl C. The Ctrl C would actually send the sigterm to that process. But let's say that's not the case. I don't want to finalize it that way, or let me cancel it again. I invoked this tool, but I use the and at the end. This is going to automatically send that process to the background, run it in the background. Well, seems like my console is locked, but I can simply hit enter here, and there it is, it's running, we can see it there, and my console is free. That's because I just appended the and at the end. If I list my processes, okay, it's running, right there, it's running. What if I want to finalize this process now, or any other process in my list of processes right here? Well, you simply need to get the number of that process, and then you can use the kill command. Well, I'll have to do it as a admin. Kill. Now, you can either use sig, let's say sig term, and then the PID. This one is 4361. Oops. There, I forgot the dash. It's supposed to have a dash here. Or I can use the number. If you remember, sigterm can be referred by the number 15. Oh, it's another process ID now, obviously. Now it's 4370 right here. There it is. So that's how you manage processes. That's how you change the state of a process. But now let me invoke this process. Let me run this process, this software once again. And if I do ps-l right there, the xsysinfo, it's right there, and we can see the priority of that process right here. Observe that by default, all processes, they have the same priority, which is 0. What if I want to change it? Well, if it's a process that is already running, a software that is already running, I can simply reinitialize that process. For example, that is 4376. So this process had priority 0. Now it has 5. Let's see. Oh, there it is. Now, actually, when I define this priority as a positive number, as a positive value, with a positive priority, I am actually saying that it is it's going to the end of the line. All the other processes have a higher priority. If I want to increase this priority, I have to use a negative number. So I have to define it as, let's say, -20. And this is, oops, there. The reason why it didn't allow me to do this is because as a regular user, I cannot define a higher priority to one of my processes. I have to be an admin to do such. That's why I had to rerun the command using sudo here. Now, when I define this priority here, -20, I'm giving it the highest priority as possible. Priority numbers range from -20, where -20 is the highest, to +19, where +19 is the lowest. So that's how you redefine priorities. Now, in case you want to run a command, start a tool, run a software, and define that niceness, define that priority. As you run the tool, as you invoke the tool, you have to run the tool using nice, the nice command, -n. Let's say I want to run it with priority 10 x sysinfo. Okay, now I have two. Let me close this one and do the dash here at the end. Oh, the end. Okay, so I have two instances. Oops, that's not what I wanted to do, but that's okay. I have two instances of xinfo running here. Let's take a look at their priorities. One is -20, the other one is 10. So that's how you define priorities. Now, just to finalize the resources that I have available in order to manage processes, you also have a very powerful and very interactive tool, which is Top. Actually, with Top, you have so many options, and you can take a look at the man page of the Top command. But most of the times, you're just going to simply run Top, and it's going to bring you the same information that the PS command brought to you, but also some other information. For example, what is the CPU load? What is the how much of your CPU is idle? So actually, in order to see how much of your CPU is busy, you have to take idleness and then do 100 minus this value right here. You also have information about your RAM, and you have information about the swap memory. So that's a total, that's free, that's used. And you also have cached or buffered. To get to the total, you have to summarize used, and you have to sum used and buffered. And there you go. So you have some detailed information. As you can see here, there are no zombie processes, there are no stopped processes. We have 171 sleeping processes and only one running process, which you can imagine that is this tool right here, the Top command itself. At some moments, at some points, we can see this number 1 changing to 3, 2, 3. That is because we have Top, this xsysinfo, and this xsysinfo. So these three tools, they're requesting computation from the CPU at specific times. So you saw how to control processes, how to list processes. We learned about the different process states, and we also saw how to define priorities to these processes. I hope you enjoyed this class. Thank you very much. Hello, welcome to our second video of Module 9, and our focus here is going to be on schedulers, tools that we have available in order to schedule tasks. Basically, obviously, there are several different ones, but mostly you're going to use two. One is to schedule tasks in a sporadic way. So let's say oh, I want to run a tool, let's say tomorrow at 10 a.m. and that's it. It'll run it once and that's it. The other one is in order to run tasks periodically. Let's say there is a backup that you have to run every day and every day of the week, and then in the weekends you run the full backup. So you run incremental backups during the week and then you run full backups during the weekend. So this is periodic. It's supposed to be a periodic scheduler. So those are the two tools that we're going to see here. The first one is the AT. Actually, it will depend on the distribution that you're using. Well, it's not showing the A. So it will depend on the distribution that you're using. Some distributions, they bring the AT tool by default. Some other distributions don't, and you have to install. We will have a module where we're going to learn how to address management tools, package management tools, but this is not the case. It's not this class. We're not going to focus on that. So for now, the Ubuntu distribution, at least 18.04 by default, does not come with the AT tool. So you have to install it. To install, you simply run apt-get space install space AT. I already have it here, so I'm going to escape that command, but that's how you do it. Now, how can you use the AT tool? Actually, it's pretty simple. You simply have to do AT space and the time that you want to, time and date, if that's the case, where you want to schedule that task. For example, let's say that right now it's evening, right? So let's take a look at the time here. So there it is. It's 8 p.m., 8 minutes, 31 seconds of that date. Let's say that I want to run a tool, run a command tomorrow at 10 a.m. So what I can simply do is AT, there. It'll bring the prompt to me. And what do I do here? I simply inform the command, the tool that I want to run. So let's say that at this time tomorrow, I want to run the /bin/ ls. I just want to list. Obviously, that it's just useless. But the idea here is simply to see that tool being scheduled. I also want to run my /usr/bin/backup.sh script. I don't have that script, but it doesn't matter. We just want to see the scheduling. So per line, you're going to inform one tool per line, one command per line. Once you're done, you're going to hit Control D. Control D as in done. There it is. Okay, so how can we know whether they've been scheduled or not? Well, you have two options. You can use AT with the -L option, or you can use ATQ. Let me clear the screen here. So if I simply do ATQ, there it is. If you don't want to run that task anymore, let's say you want to cancel it, you can do AT-R and then this number right here. It's not a process ID, it's a schedule ID. There, it's empty. So it's very simple. Now, there is a bunch of combinations that you can use in order to perform this scheduling. For example, you can do AT space the time, space the date, and the date must be formatted in that way, that form. Year with 4 digits, -month, -day. There, this date, March 3rd, 10 a.m. Oh, now, as you can see, since right now is March 2nd, so if I do, let's go back here, also the same one. There, ATQ. So this one, to schedule this one, I simply use the time. Since right now is March 1st and it's in the evening, it will assume that since I did not inform right here, I did not inform the date, only the hour, only the time, it assumes that I want to run it in the following morning, 10 a.m. in the following morning. You can also use some other keywords. For example, let's say that I use AT now. There it is, right now. I can also use tomorrow. I can use days from now. So there is a bunch of combinations that you can use. Now, that the AT tool is used to run sporadic tasks. How can you use a tool that will allow you to run periodic tasks? That is the cron tool, C-R-O-N, cron. Now, it's actually very easy as well to use the cron tool. The difference is you're not going to specify the date. You can define minute, time, day of the week, day of the month, and month. But as you can see, you cannot specify the year because it's supposed to be a periodic tool. So how can we configure a task to be periodically executed? Well, you have two different situations. One is if you want to do that type of schedule, if you want to schedule a tool, but for your own user, your user is supposed to perform that scheduling. Well, then you're going to do cron tab space -e. Well, first of all, I am the Linux user. Okay, so cron tab space -e. It will ask you which editor you want to use. And it tells you that Nano is the easiest one. You can also use Vim or Add. Personally, I prefer Vim, but it's totally up to you depending on the editor that you want to use. Now, how does it work? And it's actually explaining to you, and you even have an example here. So, let's follow the letters that we have right here. M. So the first column is used to specify the minute. The second column is used to specify the hour, age for hour. DOM, day of month. Then you have month. Then you have day of the week. And then you have the command. Now, minute, it can range from 0 to 59. Hour, it can range from 0 to 23. Day of the month, it can range from 1 to 31. Month can range from 1 to 12, where 1 is January, 12 is December. And day of the week can range from 0 to 7, where 0 is Sunday and 7 is Sunday as well, which can be kind of tricky, but it doesn't make any difference. So now here, let's say that you want to schedule, for example, this example that we have right here. We want to run this tool right here, this backup tool, use star, to run a backup at minute 0, hour 5, so that's 5 a.m. every week. So day of the month is asterisk, that's anyone. every week. Month, that's also every month. And every week, so we just pick one day of the week, in this case 1, and then you have the command that you want to run. Once it's done, so for example, let's say 30, 10, 10, 5, and it doesn't matter the day of the week, and then I want to run my /usr/sbin/backup.sh. What is it going to do? At 10:30 in the morning on May 10th, it doesn't matter what day of the week it is, because if I specify a day of the week, then it's going to be complicated, right? Because then you have to have, let's say that I define a Tuesday. Well, you have to have a day where May 10th will fall in a Tuesday. So in that case, you should just specify asterisk, anything, it doesn't matter. Now, another situation that you have is, let's say that you want to run a tool every 10 minutes. Well, if it's every 10 minutes, then I'm going to specify in the minutes column, the first one. So the way that I do it is asterisk. You could do, so you can use range or comma. So I could say 0, 10, 0, 20, I could. But it's a lot easier to do */10. That means every 10. Since I'm defining this in the columns of minutes, it's every 10 minutes. I could do, for example, 0, let's say *2, that means every 2 hours. And it must be at the o'clock time. So it would go as, let's say, 2 a.m., 4 a.m., 6 a.m., 8 a.m., so forth, so on. Okay, once you've configured it, you can simply save your file. Now, once again, it will depend on the editor that you're using. Since I'm using VI, that's how you save the file. Column WQ, there. If I want to look at my schedulings, I can use the -L option right there. Now, I clear the screen. Now, as I mentioned, I scheduled this task specifically for my user, the Linux user. What if I want to specify, to define a task that should be executed periodically for the system? It doesn't matter if I have a specific user. It's not a task that is associated with a user. It's a system task. It's supposed to be executed. For example, backups. Usually backups are supposed to be executed. It doesn't matter whether you have a specific user or not. So in that case, obviously, I have to be the root user, so I have to precede my command with sudo, and then I will edit the /etc/crontab file. So I directly edit this file. And here I do the same, so almost the same thing, with one tiny difference. We are still going to use minute, hour, let's say 2 a.m. It doesn't matter the day of the month, it doesn't matter the month, it doesn't matter the day of the week. And we do have the command, but before the command I have to specify the user. And then I do /usr/sbin/backup.sh. For example, if that's my my backup script. Now, oops. Now, the difference here is I'm specifying the user. And why do I specify the user? Because the system does not know which user can run that tool. Now, remember, this is a scheduling associated with the system. The system does not know which user has the ability, permission, to actually run that command. So you have to specify it here. That is the only difference. Another very interesting thing that you have is if you edit the /etc/crontab file, you're going to see that there are already some schedulings here. 3 actually. And they are linked to directories. The first one is the /etc/cron.daily, then /etc/cron.weekly, and then /etc/cron.monthly. That means that these are directories. Any tool, any script, any executable that you place in one of these directories or in more than one directory will be executed. Let's say, for example, if you place a script in the /etc/cron.daily, that script will be executed every day at 6:25 in the morning. If you place it in the weekly directory, it will be executed once a week. Once a week. If you place it in the monthly directory, it will be executed on every first day of the month, of every month, at 6:52 in the morning. So let me exit. If we take a look at this /etc/cron.daily, for example, there you go. All these tools are being executed every day. All these tools are being executed weekly, and all these tools are being executed monthly. So that's how you can do sporadic scheduling and also periodic scheduling. I hope you enjoyed this class. Thank you. Hello, welcome to our third video of Module 9, and here we're going to talk about logs in the Linux environment. One of the biggest differences between the Linux system and Unix and other proprietary systems such as Windows is logging. Windows does have logging, but it's not as accurate and detailed as the logging systems that we have in the open source world, which is the case of a Windows system. You have so many information, so many data, so much data that you can retrieve based on these solutions. But mostly you have to know how to configure these resources. There are several different softwares, tools to generate logs based on what happens in a system. We are going to talk about the two main ones, at least the ones that are covered in the CompTIA Linux Plus exam. Now, these are not the only two famous ones in the Linux environment. We have some others, but mostly you're going to see the rsyslog, the systemd logging system, which is called journal control, and there is also syslog-ng, although we're not going to cover syslog-ng. And syslog-ng is very much used specifically to create log servers and to send logs to servers. Okay, but our focus is going to be on the ones that the CompTIA Linux Plus exam cover, which are the systemd logging system and the rsyslog. So let's start with the rsyslog. If we take a look at the /var/log directory, that's where our log files are. So it doesn't matter which syslog system, which logging system you're using. By default, the logs will reside in this directory /var/log. And you're going to see files there according to their goal, to the type of information that they're supposed to store, log. So for example, if you want to see users that logged or were not able to log but tried to, you're going to look at so you can use the tail command to look at the alt.log file. There it is. Oh, so I can see here that some users logged in. I have the root user here, right? The root user. It's not showing here, but at some point, that's because I used the tail. But if I actually look at the greater part of that file, I'm going to see my Linux user listed there as well. So, okay, it's showing that there is a user. Okay, there you go. So my Linux user is running this tool right here. And you have so many other files in there. var log, boot.log, well, the name itself says a lot. You also have information about the kernel. It's not information, specifically information of how the kernel is behaving, or if you have errors in the kernel. At least not only that, but information that is being logged, detected, or controlled by the kernel. So if there is a tool that is controlled or invoked, has been invoked by the kernel, then it will be logged in the kern.log file. Last log for users that logged for the last time that users logged. I can also use the last log command, so there, pipe more. So it's going to show me all the users that I have and the last time that they logged in. I can see the same type of information analyzing the /var/log/last-log file. Information about the system, critical information about the system or debugging information. We have different type of data. You can see that in the syslog file. Now, what are those different types of information that we have? Let me change my screen here. Right there. So here we can observe that we have what is called the facility, and the facility will be associated with the type of information that is supposed to be logged. You can either use the facility name or the facility code, facility number. So in case you want to define that the tool that you're using to generate logs, let's say rsyslog. If you want to define rsyslog to record information about the kernel, you're going to use facility kern. You have user, which describes information that are user level messages. Mail, that are associated with the mailing system. Daemon, all types of system daemons or services running in the background. Auth, authentication and authorization. Syslog, generated by the logging system that you have. LPR, that's the logical printing system, the printer. News, if you have a news subsystem. So you have all cron, information about the tasks that's been periodically scheduled. So you have all these different types right there. Now also you have the criticality of that, or the severity of those facilities. So for example, you can have mail messages in different levels, different severities. For example, you may have information, it's just debug, notice, warning, error, critical, crit, alert, and emergency. So the lower the number is, more critical that information is. Emergency, the code is 0, alert 1, critical 2. So it ranges from 0 to 7. If you want to debug all type of information, you're going to use code 7 or debug. Now let's go back to our system here. If you want to configure syslog, you're gonna edit or create a file in the /etc/rsyslog.d directory, and then you can create a file there, or you can simply edit the 50-default.conf. Obviously, it depends on your distributions. In your distribution, that's the file that you have available in case you're using Debian or Ubuntu or Gentoo, any Debian-based distribution. There it is. So observe that it is actually pretty simple. It just follows that pattern where you're going to have the facility dot the severity. For example, here, kern, that's the facility, dot asterisk stands for debug, all type of information. It will be logged in the /var/log/kern.log. This means that, let's say that you want to change the file that will store information about the kernel. Well, you can simply add it here. Let's say that you want to define that FTP data should be logged in the /. So for example, FTP dot, but only, let's say, warn information is going to go in the var log ftp.log. That's how simple it is. Now, and then you save the file. Now, as previously mentioned, the default, the rsyslog, which is the system that we just saw how to configure, it was a default logging system in older versions. Linux systems that use the systemd software, the same one that we discussed in our previous module to control the initialization process and the invoking of other processes, they actually use the journal control tool. And the journal control tool is actually pretty simple. Well, first of all, you do have a default configuration file in the /etc/systemd/journald.conf. There you go. So you have some more generic options over there, parameters over there, but they're not important. However, you have to know that you have this file. What type of configuration can you do here? Well, you can define the maximum size of a log file. Let's say that you want to prevent from a file from increasing too much and taking a very good chunk of your storage device. Well, you can define here, you can limit a log file size to whatever it is. So basically, you can use this configuration file here to define how the journal control system or the systemd login service is going to behave. Now, you also have different ways of filtering, and this is one of the advantages of the system control tool, which is, or the login server, the systemd login server over the rsyslog. And that one of those big differences is that in the rsyslog, you have to search for the information that you need within those log files. Well, you have to do something similar when using this, the journal control or the systemd login service. However, it has a tool that will allow you to perform a filter, a very helpful filter, and it will make your life a lot easier. So for example, let's say that I want to search for logs regarding systemd, and this can be any tool, any software that's been logged in one of the log files. So I want to search my log files and I want to find occurrences, records of the systemd, but only those records where it ranges from 9 a.m. until now. Obviously, if I don't specify the date, I'm talking about the same day. And there it is. I have too much here. Let me change to, let's say, 15. There you go. Okay, so you can observe that all these records are associated with the systemd tool. All records associated with the systemd tool between 3 p.m. and now, that's the current time, and now is being displayed here. Similarly to the AT scheduler tool, you can use specific times, or you can use some keywords such as now, yesterday, a certain number of hours before. So there's a bunch of combinations that you can use. Okay, now, as previously mentioned, when you use any logging system, there is a very high probability that these log files are going to increase, maybe even exponentially. Let me use the sudo here. Maybe even exponentially. You don't want your storage device to become unavailable, and also your system becoming unavailable because, well, you didn't plan how to manage your logging service. Now, how can you prevent that from happening? Well, we saw that the systemd actually allows you to do that, but it's in a more generic way, which means that you can say, okay, the systemd login service itself and entirely cannot go over this, let's say, 1 gig. But it's not very specific. You don't have too many tools. You're very limited. To help you with that, we have the log rotate tool. And the log rotate can simply be configured using files in the /etc/logrotate.d directory. You also have the /etc/logrotate.conf file. So, first of all, the /etc/logrotate.conf file is a generic configuration file. That means that any file residing in the /var/log/syslog will have this generic configuration here. If you want to specify configuration to a file. So let's say, for example, all log files are supposed to be rotated weekly. That means that every week, the current file will be, a new log file will be generated. We'll rotate 4 files. That means that we're going to have a new file and 3 copies of the former files. That means I have a log file today. Next week, this file will become an old file, but it will still be stored in my hard drive. And then we'll have a new one. The following week, so 2 weeks from now, we're going to have 2 older files and then the new one. 3 weeks from now, we're going to have a new file and the 3 old files. 5 weeks from now, the first log file will be deleted, will be removed. So you always have 4 files. And compress, which is the default, means that the rotate files, the files that are not the current file, the current weekly file, will be compressed. Now, if you want to specify, give specific configuration to some specific files, then you have to determine that file, establish that file, and give the proper configuration. So here, specifically to the /var/log/wtmp file, we're going to also have these parameters. Missing OK, monthly, so it won't be weekly rotated. It's going to be monthly rotated, and only one rotate. So you can have these specific configurations according to the log file that you want. Or you can create in the /etc/logrotate.d a specific file, configuration file, to that specific log file. For example, let's take a look at the apt. Okay, so for those 2 specific log files, we're going to have different configuration. Actually, they have the same configuration, but it's different from the default config that we saw in the logrotate.conf file. So we saw here how we can define and reconfigure the Linux system to generate log, manage logs, and also prevent those files from occupying an entire partition. So we can define how much space each of those files will occupy. We can also define how frequently they will be rotated and so many other configuration types. Obviously, it is not our focus to cover all the possible options that we have available in the log rotate system. The exam, the CompTIA Linux Plus exam, will only cover the concepts involved in the syslog, rsyslog, the systemd, login service, and also log rotate. Only some more conceptual questions and commands and file names, but not configuration, the content of configuration files. I hope you enjoyed this class. Thank you very much. Hello, welcome to our Module 10 lab class. And you're going to observe that this lab class here actually merges modules 8, 9, and 10. So since modules 8 and 10 were some very specific modules, it would not make much sense to have separate lab classes for those specific modules. So we're going to actually present some questions here that involve all those 3 modules. Okay, so let's get started. The first question that we can see here is letter A. List the CPU or CPU's models detected during the booting process. So, well, you could, let me go to my VM here. You could go to the /proc/CPU info file, right? So there you could find that information. However, the exercise is very precise in saying, okay, it's not just showing the model, but show the model that's been detected during the booting process, which makes us believe that we have to go for the dmask command or cat/var/log/dmask. And here you can either do a pipe more and go analyzing line by line, right? Trying to find information about the CPU over here. So, okay, I can see there that it detected right here that it's the architecture, but I will have some more specific information as I scroll down. Or you could try to perform some filters here using grep. Let's say, well, I know that it's a Intel 64-bit architecture. There you go. You could filter for Intel and, oh, there it is. Right there. Okay? Actually, using this tool here, using the grep along with the dmask, grepping for the Intel string, we can even see this other information. So I also know what my Ethernet card is. So it's a Intel Pro 1000 network driver with that version. Okay, so there it is. Letter B, list all PCI devices detected during the booting process. Oh, once again, we could either do a dmask, sudo dmask pipe grep. We can try PCI lowercase. We can try PCI uppercase, or you have the iSwitch that will perform that filter and it won't be case sensitive. So I could do this. Well, there's too much information, so let me do a pipe more. Okay, there. So ACPI, okay, so we start to see some information about our PCI devices here. There. It's still, since there is a bunch of information regarding PCI devices and also ACPI, you're going to see so much information that maybe it's going to be a little difficult to find what you want to find. However, we still can. Okay, so I can see some information about my VGA card here. There's more information here. I can also see some information regarding my input device, which would be probably the keyboard. I also have information regarding my Ethernet interface. So there's that. You can do that. Another way of doing the same thing is using the LSPCI tool. There it is. Oh, okay. So there is the keyboard. There is the audio. What else? There is the SATA controller, my gigabit Ethernet controller, which is my my Ethernet interface that we saw using dmask. So yes, you can use the dmask tool to find that information, but since the dmask command will show so much data because it will show you everything that's been detected and done during the booting process. So if you have a tool that will give you specific information about what you're looking for, that's what you should use. So you could use to list your PCI devices. You can use ls PCI. USB devices, ls USB. So it depends on what you're looking for. Okay. And that is the answer to question 2 letter C. List all USB devices detected during the booting process. This is the same one. You could do ls USB or you could do dmasg pipe grep USB. List the number of existing hard drives and partitions. Also identify the file names used to identify these hard drives and partitions. Okay. So, again, you can use that. Actually, there are many different ways of finding this information. Again, we can use dmasg, and let's say I'm going to do a pipe grep -i SATA, for example. Okay, so there is some SATA devices, right? I could do SDA, for example. Let's see. Okay. So I know that for my SDA device, which is the hard drive, there it is. That's my hard drive. I also have SDA1, which is a partition. Now, what about the other possible hard drives or partitions? Well, I could do SDB. There it is. So I do have a SDB device as well. And it does have one partition, SDB1. What about SDC? Do I have SDC? Oh no, I don't have SDC, which probably means that I won't have SDD. Okay. Now, what if I had a old system, old architecture with IDE controllers? Okay, you'd have to search for HDA, HDB, which is not the case. So that's one way of doing this. The other way is simply using the fdisk tool with the -L option. Now, since this is going to show specifically because of the distribution that we're using, it's going to show so much information. I'm going to do a pipe more here. But what matters to us is, let me scroll down, and there it is. Okay. So I have my SDA of 10 gig with this partition also of 10 gig. I also have this SDB with 1 gig right there. And one partition of 1 gig as well. Then we're going to have those loop devices. Okay, so these are the 2 hard drives and the 2 partitions that we have. Now, another way of checking the hard drives that we have is listing /dev/sd*. There it is, which is actually the answer to the following questions. The following question, because actually this question is not only a single question. We have 2 questions. 1, we have to list the hard drives and partitions, and we have to show the files that represent those hard drives and partitions. So this is one way of checking the devices that you have and partitions, and also showing the files that represent them. I could do the same for HD, but there is none. Okay, so I have 2 hard drives, SDA and SDB, and 2 partitions. SDA1, that's 1 partition in this hard drive, SDB1, which is a partition in this other hard drive. And these are the files, they reside in the /dev directory. And just to remember, we could also use ls with the -L option. Oops, not this one, this one. There you go. so that we could check the type of device that we have. B as in block. Very good. Letter E. What is your network device model? And this is the answer to this question was the one that we found while searching for the Intel string. That's one possible solution. Obviously, we just got this answer here by accident, because just by chance, just by coincidence, the CPU model is the same as the of my network interface model right there. But again, we can also use LSPCI, right? And there it is. Where is it? Right here. There. Now I have some more specific information. Intel Corporation 82540 EM Gigabit Ethernet Controller. Revision 02. So again, if you have a specific tool to find the information that you need, that's what you should do. The dmask tool is very helpful, but it also gives you the level of debug is too high, so you're going to see too much information, which may make it harder for you to find the information that you're looking for. Letter F. Does your Linux system run the DH client tool? If so, what is its PID? Well, first of all, we have to remember how to check the processes that we have running or the tools that we have running. There are so many different options. Usually, you're going to use PS because this is a tool that is more simplistic, but at the same time will display all information that you need regarding processes. Because, for example, if you use top, well, the list is there, but you have to scroll the screen down. PS will just bring that PS, especially with the AUX options, will just give you the entire list of processes. Okay, what do you have to do then? You have to grep filter for DH client. Oh, so I do actually. So I do have the DH client tool running right here. And what is my PID? Right there, 10059. Okay. The next question is, which one is it? Letter G, increase the DH client process priority. Okay, so PS AUX grep DH client. The process ID is 10059. So we have to increase its priority. Okay, so that's the number. The command that we're going to use is renice space -n space the new priority. If we want to increase the priority, you have to use a negative value. So -15, for example. Well, if you want to go all the way down to the maximum priority, which is -20, that's fine. And then the PID, which is 10059. There it is. The old priority was 0, now it's -20. Letter H. How much memory does your system have? How much is free? How much is cached? To check information about memory, we can use the free command. If we don't specify the -m option, it's going to show in K bytes. If we use the -m, it's going to show in megabytes. So I have a total of approximately 2 gig. This is how much is used, a little bit over 1 gig. I have free 141, and the reason why, if we do the math here, total minus the amount that is in use, it doesn't match the amount that is free. That is because we have to, the buffer or cached memory is also available. It's not free, but it's available. So if we add up almost 700 with a little bit over 100, so that's gonna make like 840, something around that, 837 to be very precise, which is going to be the difference between this and this. Is your system using the swap memory? Let's see. The free command is also the command that you can use to gather information about swap. Oh, yes, it is using swap. Just a tiny bit, but it is. Which means that my system's performance is not as I wish it was, but at least it's using just a little bit. That's not a problem. The problem is when your free memory is 0 or very close to 0, which means that the swap memory will be used to replace that lack of RAM memory, and then you're going to see a degradation of performance. Letter J. What process is consuming more CPU? Okay, now we can go to the top command, and this is the best tool that I have available to check that type of information, because it ranks according to the, there you go, to the CPU usage. So it's always updating, it's updating every 3 seconds, but there, we can see at this very moment, this unattended upgrade is the software that is consuming so much CPU. And the next one is list all running processes. Well, we already did actually using ps space aux. That's one possibility. If you want to see all processes but list, display that result in a hierarchical structure, you can use ps3. You could do ps3. There it is. So it does show all the processes, but now they are ordered in a hierarchical way. What is your kernel version? List the kernel file. Kernel version. uname-r, there it is, 5.0.0 release 23. Where is my kernel? It resides in the /boot directory, and it's the VM Linux file. VM Linux - your kernel version. This file right here. That's my kernel. Letter M. List the last login attempts, whether failed or successful. We can use last log. Last log is going to show for each user, whether it's a administrative user, and system user or regular user, for each of those it will show the last login attempt. There it is. However, that is not what we have to find out. It wants to see all the last login attempts and not just each last login attempt for each user. So let's say that you have the same user that tried to log in, let's say 5 times in a row. Okay, I don't want to see only the last time that user tried to log in. I want to see all those 5 attempts. Therefore, I can go for the /var/log/ for example, the auth.log. That's one possibility. And another possibility is, in some systems, you have the fail log tool, which is not configured here. So in this Ubuntu system, you'd use the varlog auth.log. There it is. But again, you also have this other tool once it's configured or available in your specific distribution. Letter N. What initialization system does your Linux use? Let me clear the screen. And one good way of analyzing that is using PS3, for example. You have to check the first process. There it is. It's system D. If it was the system V, you'd see the init process, or you could show the upstart as well if it was a upstart system. Letter O, are there any log files being rotated? Which ones? So if we remember, you'd have to go to the /etc/log_rotate. First of all, you have the, actually I'm using the wrong tool here. It's not supposed to be ls, it's supposed to be more. And you take a look at the logrotate.conf file, config file. Okay, so first we have the generic configuration right here. It's valid for all files residing in the /var/log directory, but then we have the specific configs. Okay, so /var/log/wtmp, that's one. /var/log/btmp, that's another one. But are these the only ones? Well, actually, we have to take a look at the /etc/logrotate.d directory. Oh, there are a bunch of other files there. So let's take a look at those files. First of all, alternatives. Okay, alternatives. The second one, apport.log. So you go file by file. Usually, most of the times, inside the logrotate.d directory, you're going to see one config file for each log file. However, there is the possibility of having a specific config file for more than one log rotation, as this one. So the /etc/logrotate.d/apt is actually configuring rotation for 2 log files, term.log and history.log. So you'd have to do the same for each file residing in this directory, each one of these, to see what are the files that are being rotated. And the last one, use the find tool to find all block files residing in the /dev directory. Okay, so here you'd have to use the find, tool. However, you haven't learned how to use the find tool to search for specific file types. And the idea of this exercise is to actually show you how to do it. The find command, and let me use, although that's not going to be necessary, but I use sudo. The find tool is defined by find where you want to search at least the starting point, the starting directory where the search should be executed from. So it's from the /dev directory, which is going to include the subdirectories because that's how the find tool works. It's not going to only search in the directory, but also in the subdirectories. Okay, am I searching for a specific file name? No, I'm searching for a file type. So I have the -type option. And what is the file type? So let's remember, we have regular files, we have directories, we have links, we have pipes, we have sockets, we have block devices, and we have character devices. What does it ask me to do? Okay, find all block devices. There it is. So let me go back. Find in the /dev all files that are type B, which stands for block. Now, when you see that result, you may ask yourself, okay, how can I be certain whether all these files are block devices, block files or not? Well, the find tool actually has another option called exec that will allow you to run another command, an external tool, another tool on top of each file that has been found. So what is there are many actually, but one tool that will show me whether would show me the file type. Well, you can use ls with the dash L option. So I'm going to exec ls-l. Now I have to tell find that when I run ls-l, I'm running this command on each file that find finds, and each found file is replaced by the brackets. Then I do the / semicolon. And the reason is because find does not know, it knows that the command, the external command that I'm invoking or that find is supposed to invoke comes after exec. But when does it end? Because I do have the option of adding more other options after the exec option. So find knows that the command will start after exec, but when does it end? Okay, it will end when you find a / semicolon. Okay, so it knows that it's going to execute ls space -l space the file name. There you go. So as we can see here, all these files are block files. So this was a lab where we were able to work on a different number of tools, but very helpful tools when managing a Linux system, Linux environment. Also, most of these tools here should be covered in the CompTIA Linux Plus exam. So work on those as much as you can. Thank you very much. Hello, welcome to our second video on package managers. So here we're actually going to see how to use the Ubuntu package manager, which is actually the dpkg along with the apt package managers based on the Debian distribution. So first of all, the first thing that we have to do in order to understand what's going on and what we have to do is to download a tarball. So that is why I have the link here, there it is, to a tarball, which is the Apache web server tarball. In order to, from the terminal, download a file, you can use the wget tool, this tool right here. Probably your Ubuntu distribution already has the wget tool. In case it doesn't, I would advise you to actually do sudo apt-get wget. Now, this is actually me using the apt tool to download a tool, but we're going to discuss this in more details in a few minutes. But for now, in case you type wget and it says command not known or something like that. So the proper message is actually command not found. So if you type in wget and it shows command not found, that means that you don't have wget installed. That means that you have to do apt-get install wget. Okay, in my case, it's going to say, well, you already have, well, it's saying that I have that, but there is an issue with another software, which is not important at all. So basically just do sudo apt-get install wget. After that, what we have to do is to run this command here, wget with this link, this URL right here. This is going to download a tarball of the Apache web server. Since I already have it here, right here, I don't have to run it again. But once you run the wget tool, it should take, it's not a large file, so it should take just a few seconds. Once it's done, you're going to see this file right there. So if you list your current directory, you're going to see this file. By default, if you just run wget and the URL, it's going to download this, save this file in your current directory. So in my current directory, which is my home directory, now I have this file here. Now, this is a tarball. The first thing that we have to do when we download a tarball, in case we want to compile and install it, is to decompress that file or depackage that file, extract the files that are packaged in that tarball. To do such, I'm going to run the tar command because this is a tarball. So the tool that creates tarballs and extract files from tarballs is the tar command. And we have to use, so let me just go back here again. But it is not simply a tar file. It's a tar file that's been compressed using the gzip algorithm. So we have to say, okay, I want to extract files from a tarball, but that tarball has been created and compressed using the gzip file. So I have to use the Z option. X because I want to extract. If you want to, you can use the V option to perform the extraction in a verbose way, which means that it will display each file that is being extracted, and then F to specify the tarball file, which is this one. So Z because it's been compressed in the gzip format, X to extract, V to be verbose, F to specify the file, and then the file name. Once you run that, it is going to create, so if you list your current directory, once again, now you're going to see a directory with the same name of that file without the extension. So httpd-2.4.41, what do? I have to enter that directory, and here I have a bunch of files. Now, the first step is to run the config. And now, from now on, actually, you don't have to be the administrator to run the configure tool. So what the configure tool is going to do is, it is going to check whether you have all the requirements, all the prerequisites to run that tool, to install, compile and install that tool. And very quickly, so /configure to run this script right here. / and the configure script. It's going to run some tests, and very quickly it tells me, uh-oh, it's checking for a bunch of stuff, and when it checked for the APR tool, it says configure error APR not found. So you have to install that tool or that library or whatever that is. Well, okay, so if you don't have a package manager, what do you have to do? You have to go online, search for the APR tarball, try to install the APR tarball, fingers crossed, APR does not have any dependencies, which it might have. So it is very complicated. It's very time consuming. Now, obviously, we're not going to do this. If this was a tool that did not require other tools or other APIs, other libraries that did not exist in my system. So if my system had everything that was required in order to install this tool, once the /configure script was done, I would, as an administrator, sudo, I would run make. Hopefully your machine has the make tool. Well, no, it does not. So that is another tool that you'd have to install in order to compile that first tool. So you can see how time consuming this can be, how stressful this can be, because one tool can lead to other tools, At the end, you have a tree of dependencies, and none of those softwares that are needed are actually installed in your system, which makes your life a lot harder. But now let's assume that my system had everything that the Apache web server needed. It had the compiler make, so I would run sudo make, and it would tell me, it would compile the files, and then it would say done. Then I would run sudo make space install. Then my software would be installed. So once again, very time consuming, very stressful. Now, what can we do? Well, we can use the package manager, the standalone or offline package manager that we have available. In this case, it's a Ubuntu distribution, which means that we're using dpkg. Okay, so what I'm going to do is I'm going to go back to my home directory, and now you're going to download this other file here. Now, we are now downloading the Debian package for the Apache web server. So wget once again, and as previously mentioned, another issue that we have in all offline or standalone package managers is that we have to go online, find where that, let's say, .deb file or .rpm file or whatever it is, the extension of the package manager that you're using. You have to go online, find where that file, that package file is, download it, and then you can install it. So, okay, what am I doing here? Using wget to download that file. That's one possible link where you can download the, look, Apache web server, that version for Ubuntu. That's the distribution for a architecture of 64 bits, for a 64-bit architecture or CPU architecture. Okay, so as you can see here, differently from a tarball where you're going to get access to the source files, and then you're going to compile those files to your operating system, your distribution, your version, and your architecture. Here you have a pre-compiled package that contains all those files previously compiled. If they've been compiled before, you have to download to use the files that have been compiled to your distribution, to your architecture. Otherwise, they're not going to work. It would be similar to just, for example, in a Windows environment, you have a friend, or you use your desktop computer, you download a software, you install that software in a Windows environment. And let's say that software is installed in the, let's say, C:\/ documents and settings / your username, and there's the folder in there. And then what do? You copy that folder to a flash drive, you plug the flash drive in your laptop, which also has a Windows machine, which is also the same version of your Windows machine, but it's a different architecture. Then you simply copy those files, that folder, to the same location where you installed it in your desktop. Try to run it, it doesn't run. Why? Because it's been compiled for a different architecture. Okay, so you're going to download this file, and now it's a lot simpler. Let's check, it's right there. How do we install it? Oh, it's a lot simpler. Since I want to install a software, I have to be the manager, I have to be the administrator. So sudo dpkg -i, and then the file name. There, it's trying to install it. But, oh, it can't. dpkg, dependency problems prevent configuration of Apache 2. Apache 2 depends on Apache 2-bin, it depends on Apache 2-utils, it depends on Apache 2-data. So what do you have to do? You have to find those files, those packages, download those packages, try to install. Fingers crossed they don't have any other dependencies. Okay, so far it seems to be very similar to a tarball. Well, it's not. First of all, because there is a package manager, there is a tool that is controlling all the tools that are installed in your system, and where the files associated with those packages actually are. That's one. Second one, if you observed when we tried to install that package, quite instantaneously or almost instantaneously, it told me, okay, you don't have those packages. You depend on those packages, you don't have those. That is a lot different from a tarball. The tarball required you to run the /configure tool. It will look for those tools in your system, and if they don't exist, then it will tell you, okay, you need this one. Is it similar? Not quite. It's not consulting a database searching for that tool as the dpkg tool does, or any package managers. A package manager, when you say, I want to install this tool, it is going to check the dependencies, so it's going to, this package has information, so this file has information saying, I depend on these other packages. The package manager will read that information from that file and then search its database to see if your operating system has those packages or not. And then almost instantaneously, it tells me all the packages that are required and that I don't have. Whereas the /configure is going to, on the fly, search for that tool. If it doesn't exist, it will tell me. Then I'll have to install it. After I install it, I have to run the /configure again. Then it will try to find the next tool. So it's line by line. It's a interpreted configuration process. And again, there is no management. So that tool, you never know where the files have been installed unless you, during the /configure step, define where to install those files. You will never know where those files are. But again, the dpkg has its issues as well. So it says that I don't have the Apache 2-bin installed. Is that true? I can use the Apache, the dpkg-l search for Apache 2. Oops, I'm sorry. Grep Apache. And there it is. No, there isn't. So what did I do here? The dpkg with the -l option actually lists all the packages that you have installed in your system. That is why I'm going to do a pipe more here. So every package that is installed in my system is listed right here. As you can see, the dpkg is a package manager. It controls, it knows, it has a database listing, indexing every package that I have in my tool. I can actually, and I can just keep going, because I have a bunch of packages there. It's listed in alphabetical order, as you can see. So I'm just going to scroll all the way down there. A bunch of packages. Before we go back to the pipe grep Apache 2, let's take a look at some other options that we have in the dpkg tool. For example, let's say that I want not only to list the packages that I have, or I don't want to see if a specific tool is installed, but I want to see the files that were installed in my system coming from a specific package. I have this package here called core utils. There it is, version 8.28 for the Ubuntu distribution architecture, AMD 64 bits. And there is a description of that package. Okay, very good. So you can use the -l option and then the specific package name to gather information about that specific package. Great. But what if I want to see the files that were installed by installing that package? I can use the -L option. I'm going to do a pipe more here because I don't want to go all the way down. There. So all these files, all these basic tools that we have in the Linux environment, they come from the core utils package. Now, another example, let's say that I want to do the inverse. I want to know which package actually installed the, for example, /bin/ls tool. And that is the same one, core utils. So the -S is the option that will allow you to specify a file and then show the package that contains that file. Now, going back to the Apache 2 there. If I do sudo dpkg-l space Apache, just Apache there. Oh, no, there is no package, found matching Apache. But it's not actually looking for packages where there is a string Apache matching the package name. If you want to search for packages where this string matches fully or partially the package name, you have to list all packages, dpkg space -l, and then you filter for the lines containing that string, in this case Apache, which I don't have the same way. Okay, so going back to what we're trying to do, we're trying to install the Apache package. Oh, I don't want to go manually search for these packages, Apache 2-bin, Apache 2-utils, Apache 2-data. There is a chance that even these packages may have other dependencies. No, I don't want that. Therefore, the solution is using apt. Using apt, you can help your dpkg tool saying, okay, this is the package that I want to install. Find it online. I don't care where that is. Find it online. Download it. Check if there's dependencies. If there is, go back, download those dependencies, install the dependencies, and then install the package that I actually want. So, for example, I can do apt search Apache, and let me do a pipe more here. If I want to search for a package, see if there is a package with that name, or at least where part of the package's name matches my string, that's what I do. I do apt-search. Oops, my bad. apt, let me go back, apt-cache search, and then the string. There, all packages that are available online in what is called a repository are now listed for me. Now, what is this repository? Actually, the apt tool, or for example, the yum tool, is not actually just browsing the internet looking for that package. That's not what it's doing. They have what is called configured repositories. So these repositories are servers that actually host a bunch of packages. And your machine, your apt tool, will maintain a database with a list of the packages that are available in those servers, in those repositories. That means that when I do apt-cache search Apache, for example, what I'm doing is I'm locally consulting my apt package manager and asking, hey apt, is there a package or packages in our repositories called Apache? The apt tool will check the database, and its database has a list of repositories and a list of packages hosted, stored in all of those repositories. If there is, then it's going to do another thing, which is check for the dependencies. So it will check if that package has dependencies. If it does, well, in case you're trying to install, if it does, it will check if those repositories also have the dependencies. And then install the dependencies, connect those repositories or that specific repository, download the dependencies, install the dependencies, then connect the repository once again, download the package that you actually want to install, and install it. Okay, so now it has a list of packages where the name, the string Apache appears. Now I have to, according to the description right here, I have to decide which one I want to install. And the one that I want to install, as we know by now, is the Apache 2 web server. So what am I going to do? apt get space install Apache 2. There it is. Oh, now mine has an issue here. Let me fix it. And there it is. Now, to fix this dependency, it just needs to maybe remove some softwares, then it will be able to install the softwares that you're looking for. Do you want to continue? Yes. Now, observe here, the following additional packages will be installed: Apache 2, Apache 2-bin, Apache 2-data, Apache 2-utils. Remember the one that we saw when we tried to install the Apache server via Tarball, libapr. There it is. Now it also needs libapr-util. It also needs these other ones. So what does it tell us? It tells us that if I try to install the Apache web server via the Tarball, then I would have to download the Tarball for this library as well. But then maybe it would depend on this one, it would depend on this one, it would depend on this one. It would absolutely depend on the Lua library package. Probably these ones would be in the same Tarball. Probably. I cannot be certain. But for sure, this is a different package. This is a different tool. I would also have to then download this one. So you can see how problematic that can be. Now, other suggested packages that it's telling me to install are these ones. So the following new packages to be installed are these ones. And it doesn't have to remove any packages. Do you want to continue? Yes. There. Observe that it's there. It's not only downloading the Apache 2 package, but it's downloading Apache 2-data, Apache 2-utils-bin, the Apache itself, liblua, libapr-util, libapr-util-ldep, libapr-util-dbd, libapr-util itself. Once they've been downloaded, now they're being unpacked and then downloaded. Oops. And the proper, if needed, the proper user accounts, copying files to the proper directories, creating symbolic links, doing the overall configuration of your system. Okay, how do I check whether my Apache 2 web server is actually installed now? There. dpkg-l Apache 2. Okay, so now I have Apache 2 2.4.29. What are the files that were installed via this package? dpkg-L Apache 2. Let me do a pipe more. All those files. There. So that is how we can use Tarballs, package files, or apt. If you're using a Red Hat distribution, you could use yum to install packages doing an online search based on repositories. I hope you enjoyed this class. Thank you very much. Hi, welcome to our second lecture of our Module 12. And Our goal here is to learn some tools that we can use in order to learn how to manage networking in a Linux environment. So the first thing that you have to know is identify whether our system is using a DHCP server or if it's using a static IP address. Now, what is the difference? And we have to mainly understand this difference before we actually move forward. There are basically two different ways to configure your network address in your machine. Whether it doesn't matter which operating system you're using. It could be Windows, Mac, Linux, FreeBSD, whatever. It really doesn't matter. You still have these two possibilities. One is you define a fixed network configuration, which means you manually define this is the IP address and mask, net mask, and this is my gateway. It's physically defined, it's manually defined. The machine will always get that configuration unless, of course, you manually change it. Now, when you have a DHCP server and your machine is configured to be a DHCP client, what is going to happen is your machine will check if there is a DHCP server in the network. So it will broadcast, it will send a broadcast package asking for a DHCP server. Is there a DHCP server in this network? If there is, please send me a what is called DHCP offer. So if there is a DHCP server, that DHCP server will send, okay, here I am a DHCP server and this is my offer. That offer has, that's the IP address that I'm gonna give you. That's the net mask. This is the network you belong to. That's your DNS server or your DNS servers. And this is your default gateway. Then your machine will receive that offer and define that networking configuration. Next time, let's say that you restart your network service or you reboot your machine, there is a very high probability that your machine will still get the same offer. So the same IP address, the same net mask, the same gateway, the same DNS server, but it's dynamically defined, meaning that the DHCP server is the machine that is actually defining that, which means that there is a high probability that server will give you the same offer, but there is a chance that you're going to get a different offer. So the network configuration is dynamic, which means that if you have a large network, let's say with 100 workstations, it's going to be very painful to go machine by machine defining a network configuration. So it's a lot easier to have a DHCP server dynamically sending that offer to all those clients. Now, how can we identify that? First of all, there are different ways, but the most basic one is doing a PSAUX, looking for the DH client process. And there it is. I do have the DH client process running, tool running. That's the process number right there. That's the PID. So this tells me that my machine does use DHCP server. It means that it is a DHCP client. Therefore, what it tells me is that if I use IP ADDR or a IP address, you can use ADDR, that's short for address, show the network configuration that we're going to see here Well, that's the loopback interface. The loopback interface will always have this IP address here, 127.0.0.1. That's the IP address that refers to the machine itself. It's just a local IP address, not a public network IP address. This is the IP address that had been offered by the DHCP server and which I accepted. That is my IP. And my net mask is /24. That's the CIDR notation. That's the classless interdomain routing notation. So that number actually represents the number of bits 1 that I have in my mask, in my net mask. If you count 24 bits 1 represents the net mask 255.255.255.0 because I have 24 bits 1 and it's from the left to the right. 24 means that I have 3 octets of bits 1. The first 8 bits, then the second 8 bits, 8 plus 8, 16. Then another 8 bits, 8 plus 8 plus 8, 24 bits 1. The other 8 bits are set to 0. So that's the 255.255.255.0 net mask, represented in the what is called CIDR notation. Now, this is dynamic. In case I don't want to have my machine working as a DHCP client, I have to make sure that the DH client process is not running. So the first step would be to kill or stop the DH client process. That's process 18739. So I would do, let me first do a IP ADDR show here. So my IP is 10.0.2.15, okay? So I would have to make sure that the DH client process is not running. So I kill that process. 18739. There it is. Now, if I list my configuration here, we can see that my IP address is still there. Although my DH client is not running, the configuration remains. However, if I reboot my machine or if I restart my network configuration, the DH client process will go back in. Therefore, I have the /etc /sysconfig, /network sysconfig is in the Red Hat based systems. Network /interfaces file. So here in this file, I have to come here and configure let me go back there. My interface name is ENP0S3. So I have to go here and do auto ENP0S3 iFace ENP0S3 iNet static. Then I do address 10.0.2.15 netmask 255.255.255.0 and my default gateway, which is, how do I see my gateway? I still use the IP tool, but instead of checking my address, I need to check my route. There. So my default gateway is 10.0.2.2. Okay. my gateway is 10.0.2.2. That's my default gateway. Once I save that file, what I need to do is to restart the /etc/networking service. Doing that, it worked perfectly. There is a probability that you get an error message. And if that's the case, well, and assuming that your configuration file has been properly configured, you still have the chance of getting an error message. What may be happening is because the networking space restart script was not able to shut your interface down to then start it again. If that's the case, what you have to do is to do a IP address del, because you want to delete the IP address that's been previously assigned to your interface by the DHCP server. So 10.0.2.15, assuming that is your IP address. If it's not, you have to define the right one. Dev, short for device, and then the device, the network interface that actually is being used as a network interface. In my case, as we saw, it's ENP0S3. Oh, I'm sorry, I forgot to do, although it works, but it is the proper way is to define the net mask as well. Then, if we check our IP addresses, we can see that my ENP0S3 interface does not have an IP address. Now, if I try to restart my network service, there it is. Let's see. Oh, now I do have that IP address and route. I do have my default gateway. Okay, now that all that has been defined, well, I can test my network. For example, I can try to ping any IP address to see if I have a network configuration actually working, if I can establish connection. Now, what if I try to ping, let's say, google.com? Is it gonna work? Oh yes, it is working. But why? The next step, so we were able to define our IP address, we were able to define our default gateway, although I did not have to do anything regarding the router itself. I did not have to use a command to say, this is my default gateway. That's been defined in the /etc/network/interfaces file right here. Okay, so I do know that I have my IP address, I do know that I have my gateway as we saw, and I do know that I can ping a name, not only an IP address, but also a name. Well, that means that I have a DNS server configured here. But how can I verify that? How can I check if I actually do have a DNS server? Well, your DNS server is configured in the /etc/resolve.conf file. Let me go back there because I did it too quickly. That is the file. Here. So my name server is this one, 127.0.0.53. What if you want to change your DNS server? Well, you have a couple options, and it may differ according to your distribution. First of all, you can simply come here and say that I want to use the Google primary DNS server as my primary or first DNS server. Doing that. Now, there are some distributions and even different versions of the same distribution that will not use directly this file, but they will actually require you to edit a different file that will then affect this file. So you have to actually check how your distribution or the version of your distribution works. Okay, now I know that I have my DNS server configured. I know what my DNS server actually is. Now, there are some other important files still related to name solving. The /etc/resolve.conf file is the file where you can see your default DNS server or the DNS servers that you have configured. You also have local name resolution. So if we edit the /etc/hosts file, that is the local name resolution. This means that you can create in your machine. It's not configured in the DNS server. It's local. Only your machine will see that name to IP address resolution or IP address to name resolution. So for example, here I have 127.0.0.1 associated with localhost. That is why if I do, let's say, ping localhost, it's testing connection with this IP address here. It was not my default primary DNS server that did that name resolution. It was a local resolution based on the /etc/hosts file. I have this other name resolution here, and you can also, it also accepts IPv6 addressing. Let's say that you want to your machine, you want to define, for example, 10.0.2.15 is going to be my Linux machine, right there. If you want to give other names to this same IP address, you can. Just give a space here. My Ubuntu machine. There. I'm going to save this file and I'll try to ping my own machine. Oh, it's actually I forgot. So let's see. Ping my Linux machine. There it is. So the system will actually went to the /etc/hosts file and it searched for my Linux machine. It saw that that name is associated with this IP address, so that's the address that it's trying to communicate with. I can also try the other name, my Ubuntu machine. There it is. So two different names associated with the same IP address. Now, if I use the command hostname, it's showing that machine name Linux-VirtualBox. Let me try to ping Linux-VirtualBox. There it is. It is also working. Let's take a look at these /etc/hosts right there. But where does this name Linux-VirtualBox comes from? It comes from the installation process. During the installation process, you had to define a name to your machine. Once you define that name, that will become your host name. And the installation process will also add this host name to this /etc/hosts file. But let's do a test here. We can redefine our host name either by using the hostname command and then the new name, let's say, my Ubuntu VM, right there. If I now invoke the hostname command, there it is. Let me try to ping my Ubuntu VM. There. So, the same moment that you change the host name, that host name will be associated with the machine that you actually created. But let's take a look at the hosts file. Well, that name is not there. There is no problem as long as you have your hostname defined. But defining hostname simply using the hostname command, as we did right here, will not definitely impact in your system. To permanently define your new hostname, you have to edit the /etc/hostname file. Right. Oops. Right there. Oh, so I have to delete this and do my, I think it's Ubuntu VM, whatever it is. Yeah, my Ubuntu VM. Now, if I look at the content of the /etc/hostname file, there it is. If I reboot my machine, that name will be there. Now, another tool that can be very helpful when dealing with networking in the Linux environment is the traceroute command. However, when I type traceroute, it's telling me, well, there is no tool called traceroute. So let's do apt cache search traceroute. Actually, it tells me a bunch of stuff. But most likely, this is the package that I'm looking for. And according to what we learned in our previous module, when I want to install, at least in the Ubuntu system or Debian-based systems, when I want to install a package, I do sudo apt-get space install traceroute. Okay, so it's installing and it's done. Traceroute 8.8.8.8. Let's see what happens. There it is. So it is different from the ping command. What ping does is simply test the connectivity between your machine and that destination machine. Traceroute will also test the connectivity, but it will list the routers that are within that path, the routers in between the path, between the source and the destination. And we have all these gateways in that path. So first, from my machine, that package goes to 10.0.2.2, which is my default gateway. Then it's going to go to 10.0.0.1. Then it's going to go to 96.120.58.41, then 96.110.211.77, then this one, then this one, then this one, this one, this one, until it reaches the Google DNS server, or at least one of the DNS servers in Google, 8.8.8.8. So we can see here all the hops between the source and the destination, the hops within that path. All these devices here, they are routing devices or routers. Now, the Linux operating system can also be used as a router. How can we do that? And you're going to see that it's actually very, very simple. Well, first of all, my system only has one network interface, which is ENP0S3. Well, that means that at least not my virtual machine, cannot be a gateway or router for a very simple reason. A router is actually supposed to connect at least two different networks. Well, since I only have one interface, that means that I belong to only one network. It is true that I could create a virtual interface. Having one single physical interface, I could create two or more virtual interfaces. But that is another approach, which is not the case here. We're going to stick to what we have. So physically, I only have one physical interface. That means that I can only belong to one network. But let's say that I had an extra interface, network interface. That would be, for example, EMP1S2. Then, with two interfaces, I could belong to two different networks, which means that I could configure my machine to route packets from one network to the other. My machine could be used as a gateway, as a router. How do we do that in the Linux operating system? Well, first of all, we have to check the content of the /proc/sys/net/IPv4/IP_forward file, and it's set to 0. This is the file that actually determines whether my system can perform IP forwarding, which is basically forwarding packets from one interface to another interface. That is what a gateway actually does. So, yes, you're right. What we have to do is simply change the content of this file to 1, and then your machine, your Linux machine, becomes a gateway or router. Mostly a gateway, because to become a router, it has to belong to different networks. It must know routes to different networks. But to make it a gateway, I just have to change the content of this file. Okay, so that means that I could do this. So, or just edit that file. Yes, I could. But the problem is, if I do this, what I'm doing is everything that is in the /proc directory is in the RAM. It's temporary. If I reboot my machine, everything is lost, which means that every time my machine was rebooted or the network service was restarted, I would lose this configuration. Well, obviously, if I want to set up my Linux machine as a gateway, I want to make that permanent. So I have to edit the /sysctl.conf /etc/sysctl.conf file. And here, I'm going to look for this line right here. net.ipv4.ip_forward equals 1. So I uncomment this line here and save this file. From now on, every time my network service or my machine is restarted, the content of the /proc/sys/net/ipv4/IP_forward file will be 1. Therefore, my machine is a gateway. And speaking of services, another very important file that we have in the Linux system is the /etc/services file. This file has a list, actually it's a database. It's a directory, a list associating ports with protocols. So let me do a pipe more because it's a huge file. Here, it's actually telling me that the TCP/MUX protocol works on listens on port 1. Echo listens on port 7. Discard port 9. So let's say I can't quite remember what is the port used by the, for example, FTP protocol. There. I search for FTP within that file. Well, it's not actually what I'm looking for, at least not these lines here. Not even FTPS. It's not SFTP. It's not TFTP. I'm looking for FTP. Oh, ports 20 and 21. FTP uses one port to establish control, that's 21, and another port to actually transmit data, that's port 20. What is the port used by protocol HTTPS? There it is, 443. So it is a database that associates ports with protocols. And if I want to see the actual connection, so let's see, for example, we just saw that HTTPS is associated with port 443. What if I have a web server running in my machine and I want to see if that web server is actually running? Well, if I have a web server running, there are ports that are supposed to be open at least. Maybe with a few clients, with a few connections, but at least ports are supposed to be running. If it's a web server, probably the HTTP port, which is port 80, and if you have HTTPS, it should also have port 443 open. How can I actually check that? For that, you have the netstat tool. However, oops, command not found. What do I do then? Oh, I have to install a package that actually has the netstat tool. What package is that? Well, according to the package's names, there isn't a specific netstat package, but according to the packages that I have here, probably it's going to be the net tools. Let's see. So it's installing the NetTools package, and it's almost done. Now it's done, I'm going to clear the screen and try to run netstat once again. Oh, so now it's there. Let me do a pipe more here. There it is. So it's listing. First, it will list the TCP or UDP connections, and then it will list the Unix or the local pipes that we have. These are not network services, which means that what matters to us is what comes up here. But wait, does it mean that my machine has only one single TCP connection? Let's see. What if I use the -ANP? A stands for all, N stands for numbers, meaning that it's not supposed to use names but numbers, to avoid the name resolution, which demands more time. And P as in process. So the idea is to list all connections, show numbers, not names, which means that instead of showing HTTP, it should show 80, port 80, and not port HTTP. And also list the process associated with those connections. So let's take a look at it. Oh, so I don't have just that single TCP connection. I have a bunch of those. It only listed that one because that was the connection associated with my current user. So if I want to see all connections, I use the -A option. So, oh, okay. So my machine does have port 53 open, which is the DNS port. Also port 631, which is the CUPS port. That's the printing system. It also has port 80. 631 again. That's cups again, but listen on IPv6. And there are some other ports there. So that's what you have. That's why you'd use the netstat tool. In case you want to see the connections, the ports that are open in your machine. And also, if you have connections established to those ports, it's going to list those connections as well. So these are some very helpful tools and commands. So we saw how to configure the IP address, how to configure a default router, how to define a DNS server, and we also saw how to debug your networking, such as testing connectivity with ping, traceroute, using the traceroute command to see the hops within a path. And we also saw how to transform your Linux system in a gateway and verify the network connections and ports that you have available. I hope you enjoyed this class. Thank you very much. Hello, welcome to our third and last video in this container management module. And as I mentioned in the previous video, the focus of this video here is to actually see how we can interact with a running instance of a Docker container. So let's say that you have a running container and you want to actually access it to change your configuration or run commands, whatever that is that you want to do. Observe that we're not talking about how to run and how to manage the execution of an instance. We want to see how we can actually manage the configuration of a running container. So I am going to pull a Linux distribution here, specifically Fedora. So Docker pull Fedora. And there it is. If I do Docker images, I can see that Fedora is running there right now. And if we do Docker run with the -it option, okay, observe that we saw that we should run an image using -dt, and I am now running -it, and you see the difference in a second. But before, okay, so the image ID is 023, and I'm gonna specify /bin/bash. Okay, so let's understand what I'm doing here. Docker has an option, and again, Podman has the same option. They both have an option, which is the -i option, and the -i option stands for interactive. That is a situation in which you want to run a container, but you want to run that container associated, attached to a specific tool, to a specific command, to a specific application, right? In such a way that you're not going to simply run the container, but you're going to run the container and have access to the execution of that application, as you can see right here. Now, observe that this is my container. I am actually inside my container. This is the terminal of my container. Well, that's actually pretty good, right? You can see that it doesn't have the ps command. It will only have a few commands here, a few commands available, just a few files, because I am actually inside the instance. And as you know, a container is a very simplistic instance of that specific software. Okay, now the problem is, once I'm done doing what I want to do and I actually exit it, well, what we're going to see here now is Docker ps. You can see that it's not there yet. Observe that this instance here is not the Fedora instance, right? Observe, so let me do Docker images again. Observe that this is the Nginx instance that we had running before. Observe that it's been created 15 minutes ago, whereas the Fedora instance was created well, less than a minute ago, right? And we can also identify that by looking at the image ID. This is an instance of the 6b3 image, which is this one. If I do docker space ps space a, I can see that the image 023, which is the Fedora image here, is listed in the list of container processes, but it exited, right? It was terminated. And it was terminated because I instantiated it attached to a specific application, and once I exited that application, I terminated the application. Okay, so, well, now I am going to run docker rm f9a, which is this one. I am using rm, not rmi, so I do not want to delete to remove the Docker image. I want to remove the instance because it's not running anymore, right? So docker ps and docker ps-a, it's not there anymore. Okay, now what if we run it the way that we saw that we're supposed to run? So let me do docker images again because I don't remember the ID. So if I do docker run dash dt 023, as we saw before. Okay, so now if I run docker ps, it is there, it's listed there. Now that's a problem. I did not have get access to the internals of that instance. Well, how can I do such thing? Well, you can simply do docker attach and then 182. There it is. So again, I am now inside that instance. The problem here is, as soon as I exit it, right? So let me go back there. As soon as I exit it, what's going to happen is it will be terminated. It may take a while, but it will be terminated as well. If you actually observe, when I hit Ctrl-D or I type exit, it's locking the terminal. That's because it's still processing, right? So if I hit Ctrl-C, eventually it will be terminated. Oops. Okay. So a way of getting access to the terminal and not risking finalizing, terminating that machine, I want to use, so let me do docker, let me force this instance to stop. There, as you can see, once again, it's locking, right? You can see that the instance is not working properly. So docker rm 182. Okay, so a way of running an instance and actually keeping it running once you access it is you're going to run that instance just like you usually do, right? So docker run dash dt whatever, and now you're going to do docker exec dash ty. Observe that I'm using, oops, I don't know what happened here. Observe that I'm using the I option again, but I'm not using the run option, the run parameter. I'm using the exec parameter. And I need to take a look at the ID, the image ID. So docker exec dash ty, that one is 2f1. And then the application that I want to execute. There it is. So again, I have access to that instance. The instance is running. And once I exit it, I can see that I still have it running without any problems. So when I entered exit, it didn't lock the instance. Nothing wrong is happening here. So you should know that when you want to actually access an instance of a container, you run the container the same way that we saw in our last video. You use the run option, but then that is going to initialize the container. That is going to instantiate the container. After that, you use Docker with the exec parameter, the -ti option, the running Docker instance ID, and then the command, the application that you want to execute from that specific container. And then you can interact with that machine, with that instance, any way that you want. Once you're done, you can simply close it, type exit, and the instance will still be there just the same. So these are the resources that you need to know as far as container management is required for the CompTIA Linux Plus exam. I hope you enjoyed this module. Thank you very much. Hello, welcome to module 17, and this is our second video covering our Kubernetes topic. So basically what we're going to do here, or what we're going to see, is how we can set up, install and set up Kubernetes. Now, there are a few things that we have to keep in mind. The first of them is, remember that the goal of Kubernetes is to manage, is to orchestrate softwares such as Docker. So container management softwares such as Docker or Podman or so many others that are out there, right? So that means that you have to know how to configure those type of container management systems. Okay, I am assuming that you have that running. The one that I am using here is Docker, but I need you to have your container management system running. So that is the first thing. The second one is the topology. So we are going to use a topology here, which is composed of 3 computers. Specifically, I have 3 virtual machines, right? Now, why are we adopting that topology? Well, because remember, the whole point of using Kubernetes it is not simply to have one node deploying pods and those pods controlling the containers. Well, you want to implement a cluster. You want to have load balancing. You want to have high availability. So you want to create a cluster. Okay, that is one of the main advantages of using Kubernetes. Therefore, we're going to deploy 3 nodes. So in case you're going to deploy this demo here, I would like you to create 3 virtual machines, obviously, or 3 physical machines. But obviously, it will depend on the distribution that you adopt. You're going to see that right here. I am using CentOS, but you can use basically any distribution. Now, that is the third important detail. According to the distribution that you are using, you have to see how you can install the required packages, the required software for that specific distribution, right? Although it doesn't change much, because basically we have most of the distributions that we have available nowadays. They come from Red Hat, so they are Red Hat-like, or they are Debian-like, which means that they basically use either RPM, so the package manager is RPM, or Deb, okay? And in the Kubernetes website, you can see instructions on how to add the proper repositories for each of those package management softwares. But again, I am here adopting a topology composed of 3 virtual machines, 3 CentOS virtual machines using the RPM package manager. Now, why 3 virtual machines? Because in a Kubernetes deployment, we have to have the master, the Kubernetes master, and then we need to have the workers, okay? Basically, the idea of the master, Kubernetes master, is to manage. It is going to use what is called the kubelet, which is the application that implements the management software and the client softwares. So what we need to do is there's got to be a master component, a master node that will be responsible for managing itself and the other Kubernetes instances, the ones that are running the agent. The goal, the idea here is to, well, we have to remember that in a cluster, there's got to be a perfect synchronization among the components, the members of that cluster. And that's what the kubelet service does. So as you can see here, we have kube 1, we have kube 2, and we also have kube 3. So those are the 3 virtual machines. This one is the master, the other 2 are the workers or the clients. Okay, now another important detail here is that most of the commands, steps that you're going to see, they're the same for all the machines, all the nodes, whether it's the master or a worker, an agent. Okay? When you see a command, a tool, a configuration that is specific for the master or specific for the workers, I will let you know. Okay? Now, let's get started. The first thing that we need to do is to, which may seem kind of weird, especially for those people that started working on Linux a long time ago, because in the past, you would never imagine running a Linux instance without a swap partition. However, in order to run Kubernetes, we have to disable swap. So what you can do is, to run swap off -a. That is going to disable all of your swap partitions in case you have more than one. As you can see here, my swap partition is already off. You also want to make sure that whenever your machine is restarted, swap is already disabled. And you can do that by editing your /etc/fs tab, and you can comment the line that references your swap partition. So that's the first step. The second step is you have to give names to all nodes, all nodes composing your cluster, including the master. So the master and the workers. As you can observe, I have my kube 1 with name with IP address 192.168.165, kube 2 ending in 166, and kube 3 ending in 167. Okay. But I not only need to give names, DNS names to them, I also have to define that host name in your machine. So what I mean by that, it's not enough to edit the /etc/hosts, although you do have to do it. It's not enough to have the names in there, right? So you have to make sure that you have all of those names and IP addresses in there, such as kube 1, kube 2, and kube 3. But you also want to make sure that the local host name is set accordingly to the proper host name. So I can see that my master is kube 1, my first worker is kube 2, and my third worker is, my second worker is kube 3. Okay? Again, all of these steps, they should go in all machines. The next step And this is only for a deployment purpose. You do not want to do it in a production environment, but just to make our lab easier, you are supposed to check your SE Linux configuration. So by default, it should be enforcing. You want to change it to permissive, okay? And the way that you can do it is by running set enforce 0, and so that every time that you restart SE Linux or your machine, you want to have it in the permissive mode. So you want to edit the /etc/ sysconfig /SE Linux. There. You want to disable your SE Linux. Okay, now the next step is, well, there are two possibilities here. Obviously, the ideal approach is to configure your firewall and then include the ports that Kubernetes use in order to do what it does, right? So you should open those ports at least for the nodes that are involved in that cluster, that belong to that cluster. So you should allow them to communicate. Now, the problem with that is that we would have to go through a firewall configuration, which is not part of our, it's not one of our goals, right? So what I want you to do is to simply stop your firewall system. Probably by default you have firewall D running, so make sure that you do systemctl stop firewall D. Okay, you also want to actually verify that it is actually stopped. Okay, now once that's done comes a few other steps that are very much associated with Kubernetes. So you may remember that Kubernetes, it is composed of a node or nodes, right? It's running on a node. It's running pods, and those pods are running containers or managing containers, correct? Now, in order to allow the different pods and different nodes belonging to a cluster to communicate, you have a service and you have network services involved. So you may remember from the previous video that one of the things that is required is to allow bridging and allow NAT. So there is some NAT, there is some masquerading service that is required. There is also the association of your physical interface with the virtual interface created by the pods, right? Therefore, there is some networking, low-level networking configuration that is required. The first one is to allow bridging. In order to do that, you want to send value 1 to your /proc/sys/net/bridge nf-call IP tables. That is one. The other one is also to send 1 to /proc/sys/net/ipv4/IP_forward. Now, this one maybe is not necessary, but I highly recommend that you do. It is not going to cause you any harm in this scenario. And lastly, you want to make sure that your BR bridge underline net filter module is loaded. You can either check that by listing your modules, ls-mod. If it's not there, you can simply load it using the modprobe command. Okay? Now, again, I am assuming that you guys have a container management system installed and running, such as Docker, right? So if that's the case, please make sure that you have your Docker is working, and you can do that using docker run hello world, hello-world. Or using podman, same way, podman run hello world will work just the same. And as you can see, yes, it is. If you get this message, that means that it's running the hello world testing container, which means that your Docker is working, and that is a requirement. Now that we know that the container management system is working, we'll actually start working with Kubernetes. Obviously, the first step is to install Kubernetes. Before you install Kubernetes, you have to edit your /etc or your package management configuration file in any CentOS like or Debian like, any system that uses RPM, the RPM package manager, and the YUM or DNF package manager. You're gonna edit the /etc/yum /yum.repos.d/kubernetes.repo. Probably your machine won't have this file. You can just create it and then insert this command in there. Once that's done, now you can actually install Kubernetes, which is composed of kubelet, kube, ADM, and kubectl. You also want to use the option -- disable excludes equal Kubernetes. So the packages here, kubelet, kube, ADM, and kubectl, is basically, we already talked about kubelet. Kubectl is the package that contains the command line tools that you're going to use in order to manage some of the command line tools that you're going to use to manage Kubernetes, similar to the kube ADM package. Now, once that's started, make sure that your kubelet is now running. You want to start it. Since I already have it running, I am just going to double check. Let me go back. I'm just going to double check its status. So we can see here that yes, kubelet is running. Now, if you just installed it, what you want to do is to start it and then enable it, right? Because you want to have it running when the machine restarts. And then finally, now, this is specific to the master. In the master, at the end, you should run the kube ADM init command. What it's going to do is it will create the environment. It will check for dependencies. It will create directories, files. It will create all the environment that is required. Initiate services, open ports, load processes. It is basically what you need in order to have your Kubernetes master device up and running. Okay? Now, at the end of the execution of this command, you're gonna get a few commands that are supposed to be executed in order to complete this execution, to have the Kubernetes running properly through kube ADM. What that message will tell you is that you need to create a home directory, a hidden home directory for Kubernetes. So, oops, let me go back there. First, you want to create inside your home directory, you want to create the .kube directory, and in there, you want to copy the /etc/kubernetes/admin.conf file to that directory, but with the config name. So if I list my home directory, and in there I list my .kube directory, I should see the config file in there. Now, You need also to make sure that it has the proper permissions. So the config file should have read and write permissions for the owner only. And the owner and the group owner should be, obviously, it should be your user, the user that is running, invoking Kubernetes. Since I'm doing it as the root user, well, that is the owner and the group owner as well. Okay? Now, another important detail, when you are when you finalize the kubeadmin init command, it will also tell you the command that you need to execute in the worker agents so that they can connect to the master and you create a synchronous cluster. Now, you have to write it down because what it's, and I will show you in a second, but what it's going to tell you is basically that command will, that output will tell you what you're supposed to run, the command you're supposed to execute in the workers. So since the worker machines need to connect to the server, need to connect to the master, that command will tell you, hey, you need to specify the IP address of the server. You need to specify the port. And there is also a certificate that is created to make that connection, to establish a secure connection using encryption. So you're going to need a certificate. Therefore, what we're going to do now is, let's go to my Cube2 machine, which is our first worker. And again, remember that most of the commands are the same. So you have to disable swap, you have to set up the host name, you have to edit the /etc/hosts configuration file, you have to disable SC Linux or reconfigure it, you have to disable or reconfigure your firewall, you need to load the br_netfilter kernel module. You need to also enable the bridge and fcall IP tables and IP forwarding, right? You have to have Docker running. You have to test whether your Docker instance is actually working. And you need to install kubelet, kubeadm, kubectl, and have your kubelet service running. So all those steps are the same. Therefore, once I make sure that my kubelet service is running here as well, here, when I finalize, when the kubeadm init command finalized, it gave me this, well, out of that a bunch of information, it told me the command that I need to execute in my worker machines in order to connect them to the master. So this is the command that it told me. I have it here. You have to write it down to execute it there. So as you can see, kubeadm, I want to join a Kubernetes domain, a Kubernetes cluster, and the master is 192.168.1.165 using port 6443. A token has been created. Here it is. And I also need the certificate hash, which is right here. Once you do that, your worker should connect to your Kubernetes master. Now, how do I verify that? I need to run in the master server. I can run kubectl get nodes, and you can see here, and that's been implemented in the second worker as well. So I can see that all of my nodes are there. Cube 1 is ready, Cube 2 is ready, Cube 3 is ready. Now, once you've executed this command, if you go back to the server, to the master, and you run kubelet get nodes, most likely it will show your master as ready and your worker as not ready. That is because it takes a few seconds, and it's not that much. Probably it's going to take about 10 to 15 seconds so that it actually joins the cluster and that they can synchronize the information that they have to synchronize and share. Okay? So just wait a little bit, wait a few seconds, and then you can run kubectl get nodes once again up to a point that all of your participating nodes should be in a ready state. So this means that Kubernetes is up and running and Kubernetes cluster is synchronized. Your master is synchronized with the slaves or the agents or the workers. Okay, that is what you need to get Kubernetes installed, configured, and running. Now, how can we actually deploy a container to be orchestrated by Kubernetes? Well, now it's all about getting access to your container. Now, it does require a configuration file. Oh, by the way, just one detail that I forgot to mention is the networking plugin. So before you actually instantiate your container, you have to tell Kubernetes what is the networking plugin that it's going to use in order to manage the cluster, right? And that is, again, this is also done in the master. That can be done by using the kubectl apply -f. Now comes the URL of the plugin that you want to use. I mentioned in the previous video that I was going to use the Calico plugin. Okay, again, you can pick the plugin that fits your scenario better. So you do that, and then you should be able to see your participating nodes when you're done. When you do kubectl get nodes. Okay, now, how can we move forward and instantiate our container? Well, now, it is not our goal, and the certification does not exactly require you to know how to configure a file, a Kubernetes file, or an instance of a container that Kubernetes is supposed to deploy and orchestrate. But obviously, for testing purposes, we do want to do that. So gladly, Kubernetes themselves, they provide to you a sample, a file that is there just to test whether your Kubernetes deployment is working or not. So what you're going to do is, you should create, and I have it here. This is supposed to be done in the master. So I created this simplepod.yml file, and you can simply copy and paste this data in here, this information in here. Basically, I am creating a pod, okay, that is supposed to deploy a Nginx container. So the Nginx container is called Nginx. The image is this one. Well, again, this goes back to Docker or Podman, right? So you do the configuration in there, and then you simply do kubectl create -f and the YAML file that you want to deploy. Well, obviously, I already have it running here, but it will tell you that, okay, pod has been created, and then you can run kubectl get pods to verify you're running pods. And as you can see here, I do have a Nginx container running and being managed and orchestrated by Kubernetes. So as you can see, the most, let's say, complex part of deploying Kubernetes is not its configuration, because it's not having Kubernetes managing the containers or the pods. It's actually installing, configuring, and deploying Kubernetes. Again, the container that it's supposed to deploy and orchestrate depends on the container management system that you are using. Therefore, you just have to be aware that there is a bunch of steps that you need to go along to execute before you actually try to deploy Kubernetes to manage pods and containers. I hope you enjoyed this video. Thank you very much. Hello, welcome to our CompTIA Linux Plus virtualization class. And here, as I mentioned in our previous video, the idea is simply to see how you can install the KVM QEMU combination, okay? And the reason why the CompTIA Linux Plus outline file specifically refers, when it comes to virtualization, they specifically refer to KVM QEMU. The reason being, well, since this is a Linux Plus or a Linux, right, exam, they want you to know how to use tools, not only concept solutions, but also tools that are made for the Linux system, okay? So that's why they refer specifically to the KVM QEMU combination. Well, so they do not actually refer to KVM QEMU as a combined solution, but that is what is mostly deployed, okay? You can either deploy, let's say, QEMU as a type 2 hypervisor or KVM as a type 1 hypervisor, okay? But most commonly, you're going to see the combination KVM QEMU, okay? Well, before we start, let me briefly talk about these two solutions. So QEMU is just like VirtualBox, okay? It is a type 2 hypervisor. So basically, it is a hypervisor that runs on top of your operating system, okay? And you have QEMU for Windows, for example. So as an alternative to VirtualBox, if you do not want to use VirtualBox, if you do not want to use VMware Workstation, you have QEMU as an alternative, okay? But since it is a solution that was specifically created for the Linux Unix environment, it became very popular for such an operating system, okay? As far as KVM, this is a type 1 hypervisor, okay? Now, it's a type 1 hypervisor, but the way that you're going to see here, it seems like it's very similar to type 2 hypervisor, because we're going to run it on top of our Linux operating system. Well, when you have a hypervisor that is running on top of an operating system, well, that is basically a type 2 hypervisor. Yes, basically that is the case. Now, KVM independently by itself without QEMU will actually use the Linux operating system as kind of a firmware. So it uses the Linux kernel to deploy its basic functions, but it also deploys an extra module that allows virtualization, okay? So basically the idea is to use Linux as a hypervisor type 1 because it is sort of a embedded or specific or specified type of virtualization solution, okay? Very simple, very thin, let's say. It doesn't have all the modules and applications that would come along with a traditional Linux installation, okay? Now, obviously, when you combine KVM with QEMU, you're not going to have the same performance as you'd have by running KVM independently. Also, since we're not going to deploy KVM as we should deploy, if you're simply running KVM as a type 1 hypervisor, we are simply going to see how we can deploy KVM on top of our Linux instance. Okay, we're not fabricating, or we're not adjusting, we're not tailoring our Linux system to run as a type 1 hypervisor. Okay, we're just going to basically deploy an extra module that we need in order to allow the execution of KVM. Okay, but it will provide you with a much better performance compared to a traditional type 2 hypervisor. So if you compare KVM/QEMU combination with the simple QEMU deployment, KVM/QEMU will give you a much better performance compared with QEMU independently. Okay, and we're actually going to see that. So as far as the steps, pretty simple. You want to make sure that your system is up to date by running sudo apt-get update. Obviously, it depends on the Linux distribution you're using, but we're using Ubuntu as our base system, right? And then you want to run this command here. So this command, what it's going to, and you're going to see that mine will return number 0, okay? But the reason why mine is returning number 0 is because this virtual machine here, this Linux instance here is already a virtual machine. So I have my macOS running UTM, okay? So I'm using a hypervisor type 2 UTM, and my UTM is running this Linux instance. Okay, so you cannot actually use a type 2 hypervisor to virtualize a type 1 hypervisor, right? For obvious reasons. It is already a type 2 virtualization. But if you have your system and you have Linux installed directly on your system, as a traditional deployment, right? And then you run this command here, it should return a number that is different from 0, greater than 0 actually. It can be 2, it can be 10, it really doesn't matter, as long as it's a number greater than 0. Okay, so basically what it does is you are checking the /proc/cpu info file that has information, dynamic information, not a static file, right? It's information in the main memory about your CPU. So you're either searching for VMX or SVM strings in the CPU info file. If it returns a value greater than 0, that means that your CPU, as it is deployed right now, supports virtualization. Okay, and then you need to run the KVM OK command. Okay, so as you can see here, obviously mine will return an error because mine doesn't support virtualization, type 1 virtualization, for obvious reasons. But if you get this type of error here, hint, sudo modprobe kvm, it might be because you did not load the kvm module yet, right? As you can see, again, this is not the problem with my machine, obviously, with my instance, obviously. Now, if you are deploying this Linux instance on top of your physical resource, right, and you still get this type of error, what you can do in order to try to fix it is to install the CPU checker, and then you run CPU checker. So you can do apt-get install CPU checker. Okay, and as you can see, it is already installed here. Okay, then what you can, and then you run the kvm-ok command again. So then you want to install the actual packages. So here it is. You can start by installing the QEMU-KVM app, then you install the libvirt-daemon system, followed by libvirt clients, followed by bridge utils. So obviously the QEMU-KVM, that is the combination of those two applications. It will install those two applications. The libvirt-daemon system, it will install the libvirt-d-daemon. Okay, the libvirt-d-daemon is the daemon that will run the libvirt application, the libvirt service. The libvirt service is the service that will accept connections from the manager, from the tool manager. Okay, remember the virtualization management tool, you will need the libvirt-d-daemon listening on its port, accepting connections from the management tool. Okay, and then you obviously want to install the libvirt client. Right, there it is. And finally, you also need the bridge utils tool. That is the tool that will allow and implement the bridging resource for your network interface card in case you want to deploy more than one virtual machine, or simply in case you want to deploy only one virtual machine, but you want to have that virtual machine communicating with other machines in the network. Okay? Well, once that's done, what you want to do is to add the user that you're going to use to control the virtual machines, okay, to basically two groups. You want to add this user to the KVM group and also to the libvirt group. So there it is. In this case, I'm adding my user Diogo to those two groups, libvirt, KVM. Okay, well, once that's done, then you want to, there it is, you want to check the virtual machines that you currently have running. Okay, as you can see, I don't have anyone. So as you can see, the virsh tool is a tool that you can use in order to manage your instances, your virtual machine instances. Okay, so if you want to stop, if you want to run, if you want to, well, however you want to manage your virtual machines, you simply want to see the virtual machine instances that you have running, you are going to use the virsh tool. Okay. Now, in order to actually make sure that your solution is work and running, you want to make sure that your libvirt-d application, service is running. Okay, so as you can see here, yes, it is running. Okay, well, obviously, if it's not running, you want to make sure that you initiate it, and you also want to make sure that it is the service is loaded, is initiated during the boot process, right? So you want to make sure that the service is enabled. Okay. Oops, there is no D here. There it is. Okay. And then finally, you want to install the Virt Manager tool. That is the graphical user interface tool that we're gonna use. Now, again, you do not necessarily need to use Virt Manager, but this is a virtual machine management tool or virtualization management tool specifically designed to work with QEMU and KVM, and that's why we have the libvirt service running. Okay, so you need to install the Virt Manager tool by doing that. Once that's done, you just need to run your Virt Manager. Okay, and here it is. Now, you can see that just like if you've ever used VirtualBox, for example, which I believe that you have, because that was the first thing that we saw in this training, right? How to create a virtual machine, a Linux virtual machine using VirtualBox specifically. So here it is. It's a virtualization tool. You can basically now, as you can see here, you can create a new virtual machine. If you had virtualized instances, they would be listed here. It's important that when you actually run it, right, it should show here QEMU KVM here. If it doesn't, that means that probably your libvirt service is not running. Okay, now again, in my situation here, as you can see, I have an issue, and that is because I am running a virtualization, a hypervisor type 2, and then I'm trying to run hypervisor type 1 on top of that hypervisor type 2, which is not going to work. That's why when I checked the information about my CPU, we did not see the virtualization feature enabled. It returned 0, right? So basically what it's saying is, it's not that my QEMU KVM is not going to work. Well, it is going to work. The problem is, look, warning, KVM is not available. So basically, I will only have QEMU. This may mean that KVM package is not installed or the KVM kernel modules are not loaded. Your virtual machines may perform poorly. So again, it doesn't mean that it's not going to work. It will work. The problem is, it will work poorly because I'm not deploying KVM. I installed, but I'm not using KVM. Why am I not using KVM? Again, because the module is not working given my scenario, given my deployment, okay? And then from here, you can manage your virtual machines, okay? So I just wanted you to take a look at how you can install and deploy and use the QEMU KVM combination, because the CompTIA Linux Plus exam specifically in its new version specifically wants you to know how to do that. Thank you very much. Okay, welcome. As you know, in this video, the idea is to actually see how we can configure. We can put Auditd to work. How we can configure Auditd and define our rules for monitoring. Okay. So again, the first thing that you need to make sure is that you have the package installed, the Auditd package installed, and if it's running, obviously, right? So as we did that already, let me just go there, systemctl, and verify if it is running. And we can see that, yes, it's active. Okay, very good. Now, as we saw, basically, we can just start using our auditctl command, okay? So generally speaking, let's start with the watch type of rule. Generally speaking, the way that it works is we have our auditctl command -w because we're doing a watch type of rule, and then we define the path to file, the file that we want to watch, right? I use the -p option to define my permissions, meaning if any of these permissions are used, any of these attributes are used over that file, then I want to generate a report. And then, so my permissions, and then -k option with the key name that I want to assign to that specific rule. Okay, so let's take a look at a very simple example. I'm going to do audit ctl dash w space /etc/ passwd dash pwa, because I want to monitor every time that this file is written, okay, and when its attributes are changed, whatever the attributes are. And then -k again, the key name is defined by you just to make it easier for you when you use another tool, which is the AU search tool, to search for references in the log file, okay, according to this key name that you define. So I'm going to create here a user-acct key name, right? Like I mentioned in our previous video, old style watch rules are slower. Depending on the distribution, it may say, well, it is a deprecated style of rule, okay? It's not saying that it is not working. There is an error. That's not the case. Okay, also, as mentioned in our previous video, we can use the -L option to verify the rules that are applied. And we can see that this rule here has been applied. Okay, how can I verify if that is accurate? Well, just very simply, I am going to add a new user called user1. Okay, new password, user1, and I just complete everything that it asks me. Okay, well, this means that there is a write process that was applied to the /etc/passwd file. We can verify that by taking a look at the content of the /etc/passwd file, and here it is. There is this user1 account that has been created. Okay, if it is correct, right, if this rule here actually exists, and if Auditd is taking care of these tasks, monitoring these tasks, I should see an entry in my log file. Well, my log file is /var/log/audit /audit.log. Okay, and as you can see, yes, there is a entry associated with my user acct key name, right? There it is. So it's working. Now, imagine that this is, well, since I just created this new user, right? I know that it will be at the end, if not the last, at the end of the file, right? Maybe not the last one, but the second last line. It doesn't matter, it is at the end of the file. So it's pretty simple, pretty easy for me to find that occurrence there by taking a look at the tail of this file, as we saw here, right? Now, if this file is big, and it should be large, right? And what I'm looking for, I don't know when, I don't even know if there is an entry in that file, in the log file, associated with the specific event that I'm looking for. It's going to be difficult to find what I'm looking for. Yeah, sure, I could use grep to filter for a specific word, but what would that be? Would I filter for passwd, right? Yeah, sure, could work. But depending on the situation, it may not find what you're looking for, or it may result in more events, displaying more events than what you're looking for, right? So that's why we have the AU search. AU search -i-k user-acct, that is the key name that I created. And it will only list entries that are associated with that specific key name. Okay. Now observe that although the key name is user ACCT, not necessarily it will show the user key name, this specific key name that I created in all of the records. So if there is, as you can see here, you have some entries, right, that are associated with that specific event, such as here. Okay, it is associated with the /etc directory. The /etc directory holds the passwd file. So as you can see, it's the parent of that specific file, right? So it is a system call or an event that is associated with that rule that I created. Okay. Now, one problem that we have here, the way that when we create a rule using the auditctl command, this is a command that will hold its rules in the main memory, in the RAM memory. The problem with that is, well, if you reboot your system, or if the service is restarted, the Auditd service is restarted, you're going to lose those rules, right? Again, if I do auditctl-l, this rule is still here, but it's a temporary rule. I want to make it permanent, right? Obviously, I want to make it permanent. Well, the way that I can do that is by editing, and you can see that I am here in the /etc/audit directory. I want to either edit the audit.rules file that is here in this directory, or more commonly, it's not a rule, it's not a requirement, but more commonly, you should create a file or edit an existing file that resides in the subdirectory, the rules.d subdirectory. So I want to edit the rules.d audit.rules file. And in here, as you can see, I have, oh, by the way, let me first show the auditctl-s option. As I mentioned in the previous video, right? All those configuration definitions that we saw in the main page, you can define them in any file. Now, by default, you want to configure those parameters in the auditd.conf file. So if I take a look at the auditd.conf file, here it is. Like I said before, you can redefine the log file, right? You can basically redefine anything. Whether it should log local events, the max file size, the number of files that will be rotated, meaning how many log files should be backed up. It's important to mention that the Auditd service has its own log rotating system, but it's recommended that you configure the log rotate tool, as we saw. You configure the log rotate tool to monitor and control the Auditd log file, right? Because you have so many more options. It's a much more manageable and configurable tool. But anyways, all those configurations can be determined here in this file, okay? Then when it comes to the rules, it is recommended that you create a file in the rules.d subdirectory, or you simply use the audit.rules file that already exists within that subdirectory. Okay? Now, since this is a configuration file, obviously every time that you change it, you need to restart the service, right? That's how you force the service, the daemon, to reread the configuration that has been applied to that specific configuration file. So here, as you can see, I already have the same rule that I created before, right? But now I am going to make it permanent. I also created these other rules here. So let's just take a brief look at these other rules. Again, this is the same one, right? But I also created the same one for the /etc directory, okay? Which means, well, if anything happens to if any changes are made to the /etc directory, right? Well, I want to know that happened. One interesting thing that you must understand as far as permissions is that when you delete a file from a directory, what is a directory? Directory is a list of files. If you delete a file that resides in a directory, you are removing the entry, that entry, right, from the list, from the directory, which means that deleting a file is actually changing the directory. So that's why when you monitor a directory for write events, okay, you're not only monitoring, let's say, when a file is added to that directory, okay, but also when a file is deleted, removed, okay? And then, so these first two here, they continue using the watch type of rule. Now, these other three rules here, these other four rules here, you can observe that they are not the watch type, right? They are the syscall type. That's why I'm using the -A option here. So as we already discussed, -A always means that I want to activate it. I should always report, generate a log when it happens, and it should be triggered right after a system call is done, is terminated, okay? Now, what is the system call that I am going to monitor? When a file is opened, okay? Okay, well, then I need to filter to define what is the file that I am trying to monitor. So -F, dir, and I define the directory. And then I create the K, I use the K option to define my key name, right? Now, observe that basically this is doing the same thing as this one, okay? I'm just using the syscall method instead of the watch method. Now, in the previous video, we observed that we can also use the exe option, right? The exe filter to say, well, when a executable file is executed, right? Observe that I am applying the same type of syscall monitoring or audit, but to three different files, okay? Pip, npm, and cargo. That is because I just want to remind you that the CompTIA Linux plus exam requires you to understand that aside from package managers, such as the traditional package managers, such as dpkg and RPM, and also the online package managers, such as apt and yum, for example, you must also understand that some library package managers exist for specific programming languages. They are called programming language package managers, okay? And basically what they do is it makes it easier for you to install a specific library that is important that you're going to use for a specific programming language, okay? So for example, if you are going to use the Keras library because you want to use a deep learning artificial neural network, create an artificial neural network using a Python application, okay, using the Python language. Well, you're going to need the Keras. Okay, one alternative, one possibility is to use the Keras library. Well, you can, let's consider that you have Python installed in your system. One way of installing Keras is to go online, browse, download the Keras file, and then install it. Another one is to simply use pip. And pip is similar, pip, npm, and cargo. The only difference is the language that they, the programming language that they manage packages to, okay? But again, pip is very similar to apt. Remember, in apt you do apt-get install and then the package manager. Pip, you do pip install and then the library that you want to install. That's it, okay? npm does the same thing, but it's for Node.js. And cargo is for the Rust language. You also have cpan, probably cpan as far as library, programming language package management. cpan was probably the first one. It was created back in the early 2000s, and it was a Perl package manager, okay? Actually, I used it a lot, but nobody uses Perl anymore. But many people use Python, Node.js, and Rust, and that's why you have these three programming language package managers. And the CompTIA Linux Plus exam requires that you understand that this is what they do. You do not need to know how to use pip, how to use npm, how to use cargo. You just have to understand that they exist. Okay, what is the language associated with these programming language package managers? So these three rules here, what they're gonna do is basically anytime that someone installs a library for Python using pip, or Node.js for Node.js using npm, or for Rust using cargo, it will generate a record in my log file. Okay, that's the only thing that they are doing. Now I'm gonna save this file, and you must remember every time that, since we're using a configuration file, right? Every time that we modify a configuration file, we need to make sure that we restart the service. Okay, and is it actually running? Let's see. Auditd, yes, it's running, but I need to make sure that these rules have been applied. So I'm going to do audit ctl-l, and there it is, these languages. I'm sorry, these rules are there, right? Okay, let me test the etc-changes rule. I am simply going to create a new file in this /etc directory, okay, called newfile.txt. Okay, so now I am going to use the o search -i-k etc-changes, and there it is. Yes, okay, I can see that it is working. As I mentioned, it does generate a lot of output, because again, especially when I create a rule that is when I create a syscall type of rule, okay, because a syscall is not only you don't have only one syscall handling that specific event. There is many syscalls that may be triggered, and it will list all of those syscalls. Okay, so that's what you need to know as far as the audit tool. This is a very powerful tool. The reason why the CompTIA Linux Plus exam is now requiring you to understand Auditd is because it kind of became a standard when it comes to audit in the Linux operating system, and because it integrates so well with Splunk and a few other CM tools. Splunk being the most common, most famous one. Okay, so again, it's a very powerful tool and widely adopted when it comes to auditing Linux systems. Thank you very much. Hello, welcome to our CompTIA Linux Plus course, and in this video we are going to address the GnuPG tool. So the GnuPG tool is the GNU privacy guard, and this is a tool that is used basically to guarantee the privacy and integrity of files. Okay, so as you might remember, in one of our previous videos where we addressed malware and different types of attacks, we also talked about how to protect your systems against those types of attacks. When we talked about file integrity, one of the solutions that we proposed was the use of the GnuPG tool, any privacy guard tool. The GnuPG tool is the GNU privacy guard. That's the most common privacy guard tool in the Linux environment. Okay. The CompTIA Linux Plus requires you to understand not only what it's used to, but also the basics of the tool itself, the deployment of this tool itself. So the goal here is to very briefly, because there is not too much to demonstrate, not too much to do when it comes to use GnuPG. Okay, it's actually a pretty simple tool. The most important thing here is to understand the difference between a symmetric key encryption and the asymmetric key encryption, or if you prefer, the secret key encryption and the public private key encryption. Okay, so let's start with the symmetric key encryption. Let's say, and obviously I already have GnuPG installed here in my system, and I have this file here called hello.txt. This is the file that I want to encrypt, but I want to encrypt it using the symmetric key encryption or the secret key encryption. What that means is the key that I use to encrypt a file is the same key that I use to decrypt it. Okay, so basically I just need to use GnuPG-C and the file name. It will ask for a passphrase, and the passphrase is actually the secret key. Okay, which means that you're going to need the same secret, the same passphrase to decrypt this file once you get access to the encrypted file. So I'm just going to define a passphrase here. It will say, well, are you sure? And I'll say, yes, I'm sure. So it will generate this other file here, which is the hello.txt GnuPG file. If I take a look at the content, or try to take a look at the content of this file, that's what I get. Therefore, I can see that, yes, it has been encrypted. It is a ciphered text file. Okay. Well, what I'm going to do now is I am going to remove my original hello.txt file. And as you can see, I only have my ciphered file. To decrypt it, all that I need to do is to use the GnuPG command again without the -c option, just based on the extension of the file, right? You can see the .gpg there. It will know that the idea is to decrypt it. So it's saying, yeah, okay, so I try to decrypt it, and let's see. Oh, okay, so there is a hello.txt file here, and if I take a look at the content of this file, yes, it's the original content. That is the original file. Okay, so that is the simplest way of using GnuPG. But most commonly, you're going to use GnuPG to perform asymmetric encryption, okay, for numerous reasons. Most importantly, asymmetric key encryption is much more difficult to break than the symmetric key encryption. And there is a number of reasons for it. But the main reason is, imagine that you have a door, right? And behind that door, you have something that is very valuable, okay? Obviously, you want to make sure that the key that opens that door is kept in a safe location. Well, but let's say that at a specific point in time, you cannot access you cannot open the door, but you need someone to grab something for you. So you ask your wife, for example, but she needs to have access to that key. Okay, so you tell her where the key is kept. she will get the key and open the door. Okay, perfect. That works because she is the only one that has access to that key. Now imagine if you keep this key and you just leave it on your dining table, right? Well, now many people might get access to that key. It's just the same as leaving the door unlocked, leaving the door open, right? The key has no purpose anymore. So symmetric key encryption has works the same way. If you do not keep that key, the secret key, privately, then there is basically no encryption anymore, right? So if there is an information or a file that you need to share with many people, you're going to have to share that key with those people. So more than one person has access to the key, you can see the problem. The asymmetric key encryption is different. And the difference is, so let's start doing it. I created here two user accounts. We have the GPG1 and we have the GPG2 right here, as you can see. So I created these two user accounts, okay, GPG1, GPG2. The idea is I want to use GPG1, I want to create GPG1's private key and therefore GPG1's public key. Then I want to share GPG1's public key with GPG2, user GPG2. Now observe that the goal of what I'm doing here is I want to share GPG1's public key with GPG2 because I want GPG2 to be able to encrypt, to cipher information and send it to me. So observe that what is interesting here is if I create my pair of keys, my private and public key, I'm not creating that pair of key to cipher something and share the ciphered file, the ciphered information with someone. That is not my goal. I want to allow other people to have access to my public key so that they can use the public key to cipher information and send it to me. Okay? That is because only the private key can decrypt the information. So let's say that I share my public key with 10 people. All those 10 people can use my public key to cipher a file. But I am the only one that should be capable of decrypting that information. Even, let's say, if I share GPG1's public key with GPG2, and GPG2 uses GPG1's public key to encrypt a file, not even GPG2 itself will be able to decrypt that file. Because again, the file can only be decrypted by the private key, and the private key must be kept safe. No one else should have access to it. So here's what I'm going to do. I'm going to log in with GPG1. Okay, and with GPG1, I am going to generate its key using the --gen-key command. Okay, well, if you want to do that, perfect, but you have to define a real name for this user. I'm going to name it GPG1. Okay, it doesn't have to match the user name. You can pick any name that you want. Okay, I'm just gonna say GPG1 at mydomain.local. Okay, and is this information accurate? Oh, as in okay, yes, it is accurate. Well, in some systems, you might face this message here saying permission denied. That is because it will require you to define a password for the private key, and if you are using the graphical user interface, it will open a pop-up window, it will open another screen asking for that password. Well, from the terminal, you don't have permission to do that. So actually, I want to first open a screen terminal, okay, that allows me to open pop-up windows. And now I am going to generate my key. Real name, GPG1. Again, this is a process. Opening a screen terminal is only necessary if you are using the graphical user interface. And again, it basically depends on your distribution. Okay? GPG1 at mydomain.local. Obviously, it does not have to be a real domain, a valid domain. It's just an information that will be associated with that key. Okay? Okay, that is correct. See, a pop-up window. I'm going to define my passphrase here. That is correct. Although it will basically say, hey, your passphrase is not secure. That's perfectly fine. I'll just take this one anyway, and it will generate my pair of keys. Okay, it has generated my private key, and it has also generated my public key. When you do that, it will create the .GnuPG directory, subdirectory under your home directory. There it is. Now I can actually do list keys if I want to see. Oops. There it is. I forgot the second dash. So I can see here that I do have a public key right here. The UID, as you can see, is GPG1. The email associated with it is this email here. Okay, so I have my pair of keys, but what actually matters is the public key. I need to share my public key, my GPG1's public key with GPG2. So what I need to do in order to achieve that goal is to export my public key. If I simply do GPG -- export, it will send it to my console, to my default output. I want to save it in a file. I am going to name it gpg1.pub. There it is. Now what I need to do is to share this file gpg1.pub with GPG2. Now, it really doesn't matter how you are going to perform this copy, how you're going to share this public file, this key file with the other user. You just need to make sure that the other user has access to it. What I am going to do is I am going to go back to my regular user, and I am going to copy gpg1.pub to GPG2's home directory. Okay, now I am going to access GPG2. Here it is. And here I have GPG1's public key. Well, I am now GPG2. Obviously, I need to import my that GPG1's public key to my GPG2 list of keys or public key database. What I'm going to need is to import gpg1.pub. By doing this, if I want to make sure that this key has been imported, I can list my keys database, and I can see that yes, GPG1 public key is in there. As you can see, it is a public key. Okay, well, now that I have GPG2 have GPG1's public key, I am going to, so let me delete this file here. I have this file here called file.txt. Let's take a look at the content of this file. Hello, this is GPG2. I want to encrypt this file here with GPG1's public key, and then I'll share the encrypted file with GPG1. Let's see if GPG1 can decrypt it. So what I'm going to do is I am going to encrypt the file.txt file, but I need to inform which public key I am going to use. -r gpg1, I want to use gpg1's public key. This name here must be the real name. Remember when I was creating my GPG1's pair of keys, it asked for GPG1's real name. I informed this. So this gotta match the real name that is associated with the public key. Okay? And then I want to encrypt file.txt. That way. Okay, so yes, now I have file.txt.gpg over here. I'm going to go over the same process, the inverted process. I need to share this file with gpg1. So I'm going to go back to my regular user. I am going to copy /home/gpg2/file.txt.gpg to my home/gpg1 home directory. Now I'm gonna switch to gpg1. gpg1 has the file here. Obviously, if I simply try to take a look at the content of this file, I'm not able to because it is encrypted. But since it has been encrypted with my gpg1's public key, and I am gpg1 at this moment, I should be able to use my own private key to decrypt it. So gpg file.txt.gpg. Again, it's saying that I cannot do it. That's because it will ask for my private key's passphrase. So I need to actually open the screen terminal first. And now I can do gpg file.txt.gpg. I need to inform the passphrase. Here it is. And voila. Hello, this is GPG2. Okay, so very simply put, this is how you can use GPG to encrypt and decrypt a file using both symmetric and asymmetric key encryption. Observe that GPG also has the -- sign and -- verify options. So if I do gpg -- help, oops, my bad. Let me go back there. You can see that I have the -s option here. The -s option can be used to sign. The difference is it's kind of the opposite. When I want to sign something, I am going to use my private key to sign it. And those that have my public key can verify that signature. So it can be used in files, but usually this is used for emails. Let's say that you want to send an email, but you also want to allow people to confirm that this email has been sent by you. So you can use your private key to sign that email. And then you share your public key with all your other peers that should be able to verify that signature. Well, them having your public key in hand, they will be able to verify your signature. So basically, I could, again, that can be used for a file as well. So I could use the -s option to sign a file using my private key, and then I send that signed file to my destination. If my destination has my public key, they should be able to use the -- verify option. Okay. And with the -- verify option, they should be able to, let me perform a filter here. There it is. Okay, with the verify option, they should be able to verify that signature. Okay, I hope you enjoyed this video. Thank you very much.
Hello, welcome to our last video in our CompTIA Linux Plus prep course. And in this video, we are going to address how you can prep your Linux system, specifically using Ubuntu, but this is going to be the same. This is going to work the same way for any distribution, right? But how you can prep your environment to not only write, but to deploy Python code. Again, as I mentioned in our previous video, the goal here is to make sure that you have your Linux environment with supporting Python to run artificial intelligence and or machine learning applications, okay, solutions. So it's actually pretty straightforward. You just need to understand a few concepts, okay? So let's start with the how you can install Python. Well, it's pretty straightforward. As we've seen before, you're going to use the package manager that your distribution supports. Since we are using Ubuntu, you want to make sure that you are using you know what package manager you are using. So this is Ubuntu or any Debian-like Linux distribution will use the apt package manager. Okay, so I am going to verify if my Python 3 is installed. If you simply inform Python, right, there is a chance, and this will depend on the distribution. So if you simply use Python, it may find that package, maybe not. If you try only Python, it doesn't work, try Python 3. And there it is, Python is installed here. Well, if it's not, you know how to do it. apt-get install, and then the package that you are willing to install. Just make sure that it is installed, run Python 3 -- version, and again, it's confirmed that it is installed, and that's the version that I have, okay? The second thing that I want to do is to install the Python 3 pip. So probably you remember the Python installing package manager, right? In a previous module, we saw a few package managers, programming language package managers, right? One of those was pip. So Python used pip to manage its packages. So verify if you have Python 3 -pip installed. If you do not, same thing. You do apt-get install Python 3 -pip. Okay? Once you have that, then you can start using Python pip to install the packages that you need to install. Okay? Okay, now the third thing that you need to know is how to create a Python virtual environment. Now observe that this is not a requirement. In order to run applications using Python, in order to code in Python, you do not need to create a virtual environment. However, it is strongly recommended, and the CompTIA Linux Plus understands that you know that, and that's what you should do. The reason for using a virtual environment is that you want to make sure that you are jailing, you are encapsulating your development environment so that it doesn't get affected by other codes, by other programmers, for example. So let's say that this is a shared environment. If it's a shared environment, if you have a group of developers, you do not want to have one project that you're working on being impacted, being modified by another project that is being developed by other developers. That's why you want to create a virtual environment. And its creation is actually pretty simple. You are going to create a directory, and as you can see here, I created the venv directory. Okay, there it is. Now, obviously, when you create, so you're just going to, let me go back there, right? I'm in my home directory here. Just create a directory using mkdir, okay? and then you access that directory. Again, you can name it whatever you want. Once you access that directory, now you are going, and you can see that there is a subdirectory here. That's because I have created it previously. When you enter this directory, it will be empty. So what you want to do now to create the virtual environment inside this directory is Python 3-m. M stands for module. I want to use the venv module. Venv stands for virtual environment. And then you name your virtual environment. I'm naming AI underscore venv. Okay? I am going to interrupt this because I already did it. Once you do that, you're going to see an output. It will show you what it's doing. And then when it's done, you're going to see that directory, a subdirectory there with the name of the virtual environment that you have created. If we look at the content of this virtual environment, there it is. You're going to see a few files and subdirectories there, okay? In order to access this virtual environment, there is inside the bin directory, there is a activate script in there, okay? You want to invoke that script. And the way that we invoke it is by using source and then the path to that activate file this way, okay? Once you've done it, you're going to see that there is a new prompt here, okay? Before my traditional prompt, I will now see the name of my virtual environment. This shows that you are using your Python code virtual environment, okay? Now, inside this environment, I have the same files. The only difference, again, is that I am protecting this code so that it doesn't extrapolate. It doesn't go and touch other projects, and I do not allow other projects to touch my files here either. Now, that's all that you need in order to get your Python environment running. Now you can just start coding. Just to associate this with with machine learning and, well, specifically generative AI, let's take a look at a very small simple code in Python that you can leverage in order to write a NLP system, okay, a natural language processing system, which is, so NLP, natural language processing, is the most common language when it comes to coding AI systems, okay? So let's take a look at this code here. This is, again, a very simple code. And in Python, as in any language, right, you have a specific structure. Now, one very interesting thing in Python is that the number of libraries and APIs that you have available is just impressive. There are APIs and libraries for Python to do basically anything. You just need to know what API you got to import into your code. So here I am importing the NLTK library API, okay? And then once I imported it, I can basically use the methods that are provided by that specific API. First, I am using the NLTK API with the download method. I'm using the download method to import another method. That's the punct tab. The punct tab is a method that is used to perform tokenization. Okay, tokenization is a resource, a method that you can use in AI, very common in AI, to split the string, the text, the information, the request sent by the user. So for example, let's say that my user is sending a question. I want to learn more about natural language processing. Well, each word, so this entire string should be broken down. Well, that's one approach, okay? not necessarily you have to do that, but that's a very common approach, is to break that string down into blocks. Each word will be a block or a token, so that your NLP system can process each word, trying to identify the most important ones, the ones that more precisely dictate or identify what the user is trying to do. Okay? So then this is my string, and I tokenize this string. So again, a very simple use of the NLP language. Again, this is not actually processing, this is not actually using AI. It's just preparing the system, tokenizing the system to then feed these tokens to the AI system. Okay? So a very, very simple code, and then I can finally run this code here. Observe that all that it did was to break it down into those words, break those words down into a vector or array. So this array has positions 0, 1, 2, 3, 4, and 5. Natural in position 1, language position 2, processing position 3, is position 4, here position 5, well actually 6 position, and then the exclamation mark point in the last position, the 6th position. Okay? So that's how you can prep your environment, your Linux environment, to use Python, and also to incorporate Python, allow your Python environment to write codes in AI and leverage AI. Thank you very much. I hope you enjoyed this video.